Mic is on.
Good evening. On behalf of SARC, I welcome all the members for CPE meeting on cloud security. It's my privilege to invite the speaker, Mr. Sridharan, onto the dais, please. A round of applause, please. I request all the members to please raise for the institute motto, please. Thank you. A brief about the speaker. Mr. Sridharan has about 2 decades of experience in information technology and security in cloud computing industry. He is currently the Director of Compliance at Zoho Corporation. He is also the Data Protection Officer for Zoho. He was instrumental in design and architecture of the Zoho's IT infrastructure as well as the cloud infrastructure. He was also instrumental in setting up of application security team and organization policy frameworks for good governance. Prior to his association with information technology industry, he was in the utility industry for about a decade, wherein he was involved in commissioning and operating power plants. He is a bachelor in electronics and communication and MS in software from BITS Pilani. The session is yours.
Good evening, everybody. I hope I'm audible, and this is going to be what, 2 or 3 hour long session. So are you all prepared? So let me see how I can make this interesting, and I'll also try to make it a bit more interactive. If you have any doubts, you can just stop me in the middle and then we can have a chat. So you are all chartered accountants, so I come from a completely different domain. Even though I have done my CISA, so I know a bit of auditing, understanding about auditing, but mostly from the information security perspective rather than the financial perspective. So Zoho, as you all know, is one of the top software as a service provider in the world, and conceived and developed in India. So I will just try to explain what this whole cloud computing is about first, and then what security is. What do you mean by security? What is privacy? So I'll also talk a bit about privacy also in between, mainly because privacy is becoming something very important, just like what security was probably a few years before. And soon you are going to have a privacy regulation also in India. So I'll just try to mix security, privacy, and then the concepts about what they mean, and then let's see how they are implemented in the cloud, or how is security implemented in the cloud. So you can feel free to ask me questions in the in between. Okay, so before we start even about cloud computing, I wanted to talk a few minutes about computing itself. So, what is the earliest computing revolution or something that you can talk about? I mean, can somebody say what is the earliest computing? Famous word, earliest computing. Any answers? Nowadays, I think only some people from TCS and Infosys run those as projects for some of the major companies. Okay, so I'll go to the slide. So the first was the mainframes, right? So these used to be big machines occupying whole rooms, just like what data centers are these days. But then there's a subtle difference, we'll come to it later. But the problem was that the mainframes can only be used by people in a serial fashion. So the jobs are submitted, the jobs get executed one by one, and then finally the whole job gets completed. Then what happened? We had the desktop or the PC revolution. What people thought was that it's taking a very long time to get that resource, it's very costly. So why don't we push the computing power onto the desktops and the laptops? So that's why we all have computing power, and the biggest computing power these days is this phones, right? These are very powerful devices now. I mean, I think about 10-15 years before, we used to have this button phones, right? That's the only phone. My first mobile phone happened to be an Ericsson phone, which was like a brick, like a walkie-talkie. That what the police and everybody used. That was the mobile phone. From there we have come here, right? So the computing has spread into our palms. But can this do that amount of computing? Yes, partially yes. But you still need something at the back end for these devices to work. So at the back end is what is the cloud computing. So I have just not depicted the cloud here. So the cloud computing is where the entire back end of whatever happens in the phone happens. For example, I had to come here. So I used Google Maps. Can all the map data be stored in this machine? No. Can the route be stored? Partially yes. Can the traffic data be stored? No. Obviously not. Because the traffic data has to come from different places, get aggregated, computed, and then it has to come into this phone. So obviously this needs a lot of power, computing power. So where does this computing power stay? That stays in the cloud. Now, if I am navigating from my home to this place, it has to show me the route for just from my house to this place. And you may be coming from a different location and you should get a different route. Both the routes will not be the same. So, how does this happen? Does it mean that they have one computer for each of us? Is it possible? I mean, is it possible for them to build like, okay, so every single time a user joins Google, I will build a computer, right? So these kind of things are not possible. So how does it happen? What is cloud computing? And those things we will discuss as we move forward. Now, in short, if we talk about evolution of computing, we have still not come into the cloud computing as such. We are only talking about computing, right? So if you see the evolution of computing today, it's basically about scarcity to abundance. So, I'm not sure, when we studied in the college, to get into the computer room and get a computer used to be something like a gold medal for us. Because you had computers only in some places. None of us had computers in our home, right? So that was how it was. Now how many computers do we have in our house? Each person has one computer, right? So that's how the abundance of computing has happened, right? Now the other thing is transactional to disjointed queues. What does that mean? It means that computing is not about transaction. So if I am navigating from my house to this, So the computer sitting in the center will not say, wait, this guy is moving from that place to this place, I will first finish his job and then come to you. Then how can we take care of so many requests, right? So the disjointed queues. So I keep on sending data about my location, and it constantly checks, does the computation, and then gives the next turn for me. While it is performing the same thing for n number of people all around the world, right? So that's the disjointed computing or queues that we have right now. Now, if you had heard about mainframes, they always used to talk about how to improve the performance and hardware centric, right? So how to make it probably compute faster. From there, what has happened here is we have moved towards convenience and choice in the sense that we would not really, for example, if the Google is a bit slow in giving you the address, you are still okay with that, right? For 90% of our activities, we don't need something that has to be done right away, right? You understand that, okay, there will be some delay and it is acceptable, right? So convenience and choice. And what did we get because of this convenience and choice is because the computing could actually spread all across. Now everyone has got access to the computing power, right? Then if you talk about the other thing, which is hardware centric to software centric. Now, when I mean hardware centric to software centric, much of what runs cloud today are not very different from the servers that you and I, servers in general, right, are just the normal machines that we use in our home, but okay, slightly performance oriented, but not that much different. You can in fact have some gaming laptops which are having the similar kind of power, right? So what then does this cloud computing does is the software centricity. It uses the software to actually partition the amount of computing resource that is available and try to cater to a large volume of requests. Okay, so is it Greek and Latin now, or do you think I can continue in the same way, or do you think I have to change something? Continue, right? So this is not Greek and Latin, right? I am able to convey what in a simple terms, right? Okay. Now let me go to the. So now what we are trying to do is to understand what this whole cloud computing is about, because the cloud itself is like what you can call that elephant story, right? People talk about cloud. So one person looks at the legs and thinks cloud is this. Another person looks at the trunk and then he thinks that that is what cloud is about. So we use cloud a lot, but we still don't know very much about what the basis of the cloud is. What do you mean by a cloud? And so what's the definition? What are the characteristics? So what is the benefit? I think many of you would know about the benefit, so I would let you talk about it. And then implementation, yes, implementation. How is it implemented? What are all the backend? What do they do it to implement issues, and then the other thing, right? Okay, so whenever we look at the definition, whenever I come to a presentation, I just look at some standards because they usually try to explain a complex subject into something that is very simple, right? So this is the definition of cloud as per NIST. So NIST is the standards body of United States of America. So they have a lot of guidance on a lot of subjects, and this is about cloud computing. Okay, so these are the words. Ubiquitous. This is a model. So cloud computing is a model for enabling ubiquitous. Any idea what ubiquitous means? Prevalent, everywhere available, right? Ubiquitous, convenient, on-demand network access to shared pool of configurable computing resources, rapidly provisioned and released. So I have just tried to make the important words bold there. So ubiquitous means it should be available, widespread, availability. Convenient. It must be convenient to use. It must be imperceptible. We should not be doing a lot of configurations to access that service. Even a layman should be able to use it, assuming that the person knows the domain. For example, I have a finance software. So I must only know the domain knowledge of how to use the finance software. I should not be really worried about what happens in the back end. You have to do the right click, left click, nothing. So you just go and then start using it. Convenient. On-demand network access. So on demand, you should be able to actually access the network to fetch the resources. And recently in the cloud paradigm, we also support offline computing. So we can store a portion of the data in your local machine, and we can sync as and when the network becomes available. Because when you move on a mobile network, you don't actually get the permanent connectivity. The connectivity can go and come, right? So on-demand network access to shared pool of resources. The resources are all shared. So it's just like a hotel room, right? So it's the data center is shared by millions and millions of people, right? So that's the shared pool of configurable computing resources, which means the computing resources can be configurable. For example, today, let's say ESPN or something, right? There is a India-Pakistan match. So the number of people will be more. So I should be able to ramp up everything and then serve most of the people. And then there is some Afghanistan versus Ireland match. So I don't need those many resources. I can bring them down. So right. So configurable computing and rapidly provisioning and released. So you can rapidly provision. So at the click of a button, you will say add 5 more computing resources, add 6 more computing resources, extend the endpoint to multiple geographies. So these kind of things you will actually do a click and point and start. This is what you will do, and then at the back end all these things get automated and then the resources get provisioned. So this is the cloud computing definition, right? So now let's go to the characteristics. So this slide is just the extension of the previous slide, right? On demand nature. Yeah.
This GST side, most of the time it crashes.
Which one?
GST side. When the number of users are very few compared to the Google users, that's why we are facing this problem for last 2 years.
See, so this is very important in cloud computing, right? The most important thing with cloud computing is that how well you are able to manage the shared resources. I'll give you a simple example that can happen in a hotel. We'll take a hotel, right? So how many of you have an engineering background or a science background here? Okay. So you heard about Poisson distribution, right? So let's assume that I am running a hotel. So how many rooms should I have? Is a question. So I am going to start a hotel now. How many rooms should I have? Now this is a common problem. When there is, let's assume there is a Tiruvizha somewhere, right? Just on the Tiruvizha day, there will be lots of people. So what will happen? Rooms will not be available. But on days when there is nobody there, all the rooms will be empty. So what do you build for? Do you build for the Tiruvizha or do you build for the lean days? We will build for something in between. So there is this Poisson distribution which will estimate based on things how many people come. So they will say at this point there is a probability that when the crowd is this much, you will be able to cater to these many set of people, right? Now, I think the GST problems, usually what I have heard about, I may be wrong, you are better informed on that. It all happens during that phase when all the people try to go and access the site. This happens even with the IT also, I mean the IT returns also. Why go that far? IRCTC, Tatkal, right? So, basically Google and Microsoft, those people, they have unlimited computing resources. When I say unlimited, the amount of provisioning that they do for this computing resources is very huge. I mean, for example, for everybody they give you about what? 25 GB of space or 10 GB of space or 5 GB of space. So how much of 5 GB you are going to use? I mean, 5 GB now is not a big amount. I think they give about 20 GB or 25 GB of space. 25 GB, how many of us will be using? Right? So they give you 25 GB, but they know very well that you are not going to use 25 GB. So they will do planning for that. So I would think that it all depends on how you plan for it, and there can be two reasons why this thing happens. One is the real computing power problem. The other is the network problem. If the network is also not provisioned properly, then also you will have a problem. That is, there is lot of, it's just like our Madras roads. Wherever Chennai, there is this bridge work going on, you will see that side will be free, this side will be free, just the place where there is this road work going on, you will have tight congestion. So you will not be able to reach there. You will not be able to reach there only because of this constriction. So network is one of the reasons why it can be, and the second reason can also be the improper provisioning of the computing resources. The computing resources have to be estimated. So the estimates have to be done. Okay, if these many reports are going to be filed, so how much are you going to invest in that? So this is actually a very big area within cloud computing. So the major cloud computing providers, including us, we will keep on evaluating the performance. In Zoho, for example, each and every machine actually looks at how loaded it is. Each of this is actually collected, just like sensors. You have sensors in all the machines. It will tell, okay, one machine may actually have a faulty network card. It may have lots of resource, but it may have a faulty network card. So that will not be able to serve. So all this in the back end, you have to constantly keep on watching and then throw some servers out. So sometimes you will throw some servers out because they are actually slowing down the system. And instead we will provision new. All this needs to be automated, and this is actually a big science by itself. So I can't answer for who is running that, but this is kind of...
Infosys is handling it.
Actually, they have officially admitted that the peak availability 1.5 lakhs users. That officially they have declared.
So that is what they have provision for. So it all depends on, as we go down the line, we will see how you have to actually, how availability is important, and then, so first what you have to do is your SLA. You have to first determine what is your load, and based on that you have to build your infrastructure, right? And even one...
What is the solution to this recurring problem? We are facing every month, we are facing...
The solution is basically you increase the computing resources, right? So increasing the computing resources, I mean, you have to understand what really is the problem. So I can give you some examples. For example, very early in our history, this is about like 15 years before, if I'm right, 50, maybe like 13 years before, there was this new pay commission that was announced. So one public sector employee did an Excel calculation of the new pay structure, and he put it on the Zoho, right? It so happened that that particular service almost came to a crawl, because Zoho is like, at least in the case of GST, you know what the application is going to do. In our case, we also don't know what application is going to be used for. It can be used by anybody, right? So we make available software which is used by everybody. Now what happened? That is when we decided to do this one. So when we actually went and looked at the problem, we found out that it was because of this one page which was having too many requests, and the too many requests did not have sufficient capacity in the backend. I am talking about lot of years before. So but we learned from that. So what we did was we used that as a test case, and then we understood that we have to not just monitor the amount of traffic that is coming in, because usually the kind of pipes that we have or the network resources that we have is very huge. So even if there is a very small spike in the traffic, it is not big for us because we have that much of capacity. But that small spike may have a big impact on some app server, some server which is actually handling that load. That server may not be having the capacity to take that much of load, right? So it is not just important to only focus on just the network capacity or the system capacity. You have to actually look at each and every individual server and then try to gather the details from that server, and that is what we developed. So we actually developed a complete orchestration system which will actually look at, it will be able to find out whether it is because of a disk problem or whether it's because of a network problem or whether there is a computing problem. There can be a computing problem also. I mean, we are all human beings, right? We write code. Sometimes the code may be wrong, or the code may not actually be written for a certain scenario. Suddenly when the traffic comes, it may start misbehaving. So all these things are possible. Now if that is the case, we have to first identify which exactly is the problem, and then based on that particular issue, and this has to be done real time. So if you find that a certain computer is actually having a big issue, then you just pull it down, give euthanasia, so that at least the requests that are coming to that computer will actually get redirected to something else, right? So these are some of the things that we do. I think I'm actually jumping the slides and moving forward, but these are all the things that need to be done. So as the sir is saying, if they are acknowledging it, then that design itself is probably designed for a certain kind of a workload, and the workload that they are getting is higher than that probably. Maybe they would have looked at the VAT numbers and would have designed for VAT numbers. Now GST numbers may be very high, and then the GST, the requirement for the GST to have so many submissions, they would not have factored in. I cannot actually exactly say this is the reason.
2 years is too long a time to...
Probably that's something an Infosys guy can come and maybe...
2 days back, that NRC data, the cloud disappeared in Assam. That came.
Yeah.
The NRC, Assam, they did the NRC, no? That data suddenly disappeared 1 week back. Now they found out Wipro is due, they are due about 2,000-3,000 crores backlog. So they simply plug the connection. And they finally found out one staff was having a Gmail ID to operate that. That person has resigned and gone. They didn't share the password. If that is good.
Yeah, so
you can only speculate.
Yeah, so this is the interesting thing about the cloud computing. We'll come to it. All these things are actually covered in the subsequent slides. So the pain points, everything is covered. So we'll just slowly move forward and then we'll come to those areas. These all areas will be covered. Because when you actually depend on somebody else, now it all depends on whether you want to do the work yourself or whether you want to trust it with somebody else, right? So this is what cloud computing is. So when you trust with somebody else, you should have a proper contract, right? So without a contract or without knowing yeah, there is, no, I'll come to the subsequent slides. You will just understand how the people and the data, everything plays a role here. So as far as the characteristics are concerned, so I explained almost most of the things in the previous slide. So yeah, so this is very important here. This for auditors, cost based on use, OPEX versus CAPEX. So for auditors, the most important thing that you have to remember is cloud computing is mostly OPEX, not CAPEX. That is, every month on month you will pay something, right? So sir was saying that the due is about that many number of crores. This would not have done, this would not have accumulated in 1 month. They would not have paid for so many years, right? So the cost structure of cloud is always OPEX. Now why do people prefer that? Again, the same hotel example. Whether you want to build a hotel, every place you have an office. For example, from my company, assume that I am traveling to US, right? So is it possible for Zoho to build a hotel at every place the employees travel? No. What they will do is they will try to use the shared accommodation, right? So in those places where the people can share, there they can use this OPEX model rather than spending on the CAPEX model. So there is also something called as horizontal scaling versus vertical scaling. Let's take this example. Let's go to our own house. iOS or any Android, they first start with one version, right? Then what do? They go for, so first they will start with some iOS 7, then they will say iOS 8, then they will say iOS 9, then they will say iOS 10. When iOS 10 comes, the phone that was shipped with iOS 5 is practically like a brick. You can't use it. Now what you have to do? You have to upgrade. What upgrade? The processing power that is there in this phone has to be upgraded. That's what happens, right? So this is what happens in typical industries where you don't use the cloud. For example, I have a server. I have about 200 employees. Now I become 2000 employees. The server, the ERP server or something that I am keeping at my office has to now scale for 2000 people. So what should I do? I have to jump that machine, probably buy another machine and increase the so this is called as vertical scaling. What do you mean by vertical scaling? You actually have to increase the capacity. There will be still that one machine or two machines or three machines, but each of them will be having higher capacity, right? So this is the, and who foots the bill for this? The company fits, the organization foots the bill for this. It has to do the upgrade. For every upgrade, you also know there is a change management. So you know how typically we do the things, right? So suddenly we want to do some change, we will not plan for it, we will simply go and change something. Some data will be lost, some data will be irrecoverable, some data, and sometimes it may also be that the change in OS may make something corrupted. Now you have to figure out all these things, how to first convert from this data structure to that data structure. You forget about all the other things. This PowerPoint presentation, I made a PowerPoint presentation. Now suddenly in one machine it says some of the images are gone, right? So now then finally what I did was I exported it as a PDF. So this presentation itself I made it in Zoho. But then when I export it as PowerPoint, in certain PowerPoint versions it works well. In some others it does not work well. So this also happens, right? Even though the format is the same, .pptx or whatever. So then I changed it into this PDF. So now PDF probably it's giving me these images and stuff like that. So this OPEX versus CAPEX, horizontal versus vertical scaling is something that is of interest to auditors. And I will touch upon a very interesting point because of this OPEX versus CAPEX and how it is useful for auditors when I come subsequently to the ISACA guidelines on how to evaluate cloud computing and stuff like that. Now, another common misconception is that virtualization means cloud. So, virtualization, how many of you are aware of virtualization? Okay, so virtualization means today we have a computer, big computer, right? So, whatever computer that we have, I can actually run another computer within that computer. That is called virtualization. So virtually you can have many machines provided you have that much of power. So some of these gaming laptops, they have very good power. So typically these engineering students, they run 2 or 3 operating systems because they have to learn Linux, they have to learn Windows, they have to learn multiple softwares, multiple systems, right? Say Java. So for Java they will have an environment, they will put it as a virtual machine. For Python, they will put another virtual machine. So they will keep all these virtual machines and then they will use. So the computer itself will be just that one single computer, but inside that there will be many computers that are actually capable of being run from. So that is virtualization, but that virtualization is not cloud. So cloud is not just about taking the resources and then putting it in one computer and then giving it. So that's not cloud. So let's go to the benefits. So some of the benefits are the agility. The SARS question on GST, the agility is broken, but agility is supposed to be one of the big benefits. What does agility mean? Agility means that you are able to configure and provision servers and services on demand in the like this, right? So typically this is not something that you will expect without any knowledge from your side. So I'll make it a bit clear here. So when I say agility, the agility is not just about what the system has in the back end, it also is about how good you are able to use that agility. For example, if you take Amazon, right? In Amazon you can provision a lot of things, and then you can also give load balancers, you can provision a lot of things. You can say that at the minimum level I want some 10 servers, at the maximum level I want some 20 servers, and all these things you can do. But that is only useful if you are exactly able to calculate the load and then properly configure it. If the configuration is improper, even though there is in the back end lot of computing resources that are available, they still may not be properly utilized, right? So the agility is not just about what the platform provides, it is also about how well we are able to configure. So the IT guy or the guy who is actually going to look into this cloud computing administration, so that is why these days Amazon has got a certification for these kind of work. Why do you need a certification? Because it's not enough that you know that there is something that is in the backend that can scale up. You should be able to provision, you should be able to continuously monitor how the resources are being used, and then based on that you should be able to change. For example, if you are seeing that gradually, so for example, today I open a new shop, few people will come. 1 month down the line, 2 months down the line, there will be more people, right? So the amount of things that I store cannot be the same 10 months from when I started. So when you start with a certain inventory, and then you slowly keep on increasing the inventory, looking at how the inventory is moving from the shop. So similarly, you will have to continuously monitor how the usage is, and based on that, in the back end, the resources have to be built. That is why in Amazon, they also have an alternate way where you can actually get committed performance also. In some of the, so if you pay less, you will get less committed performance. If you pay more, you will get committed performance. So people who run big loads, I think Netflix and all, they used to run on Amazon, basically, completely. So they will be actually using a higher capacity and guaranteed capacity of computing resources. Right? So agility is there in the system, but it also depends on the skill of the person. Right? Now, cost containment. Why is the cost contained? The cost is contained because upfront you are not paying for the hardware cost. So if the server had to be put in the server room of the organization, first you should have a server room. That is real estate cost. Second, you should have a server. So this iPhone, the latest model will cost some X amount of rupees. 2 years down the line, the price will come down. So when you actually purchase some resource, which is the top end for that particular time, that will be costly. Then in 2 years time, that will not be useful. Then again you will go and purchase a top line server again. That top line server again you will pay the cost. So these are all the costs that you pay. Versus in the case of a cloud, this cost need not be paid, because what we are paying for is just the service. All this is the headache of the cloud service provider. Again, I'll give you, there are different types of clouds. The cloud is not just one dark black cloud. This is various shades of cloud. I'll just explain what those clouds are. So then you will be able to appreciate why I am saying this. Then expert management. See, if you take our own company as an example, right? So somewhere around like 20 years before, we were just a startup. So we used to buy some servers, then we just used to run them. Then we find the same problems that I have described till now. How we came into the cloud itself is something like the problems that we faced. The exact problems that I'm saying right now about how much money we are paying for the server and then how we are going to. So then you will actually get a software from some vendor. Now you are completely dependent on that vendor. So how much does a ERP implementation cost and how much is the ERP implementation time? Typical? Huh?
Minimum 1 year.
6 months to 1 year.
1 year.
1 year. And amount of money?
Depending upon the size.
And how much of effort that we have to put, and how much of the times they will say this is what is possible, this is not, beyond this is not possible, right? So whichever way you go, there you get locked into that kind of a system. And you should also have an expert to manage this. The person in the IT department should know how to start the server, stop the server, not take the backup. All these things, all these the things that are needed for the proper operation of the system has to be done by a local IT guy. So you need to hire very good IT guys. Now, by the time you actually train the IT guys, the system itself would have changed. Then again they have to go retrain. The retraining cost as well as the time taken for them to actually move from one time to this time. So when I studied engineering, the only programming was probably C and Fortran. Right? So over these 30 years, how many languages have come? How many different technologies have come? We have to keep on skilling ourselves. If we don't skill ourselves, we will kill ourselves. Right? So the expert management is actually a very difficult thing. But if you actually trust it with the cloud service providers, so they will have the best people to manage this. Because they can afford it. Because for them, it is something that they have to do as a part of their business. So that also gives you a bit of reliability. Again, I will say Google Maps, it's more reliable, right? Like 90%, 90 to 95% of the time it actually takes us to the, at least it says whether, and these days if you see, the estimated time is very close to actually the time that we go and reach. So it's slowly becoming better. The reliability is because the experts are actually working on the problem. Right? Now, so we talked about the characteristics and then we talked about the benefits. Now I am going to give you some brief tips on how it is being implemented. Right? So one thing that we do is multi-tenancy. So I think this is a straightforward term, multi-tenancy. So multi-tenancy means many people are sharing the same resources. So there is a big, we have a big platform for that. So in Zoho there is a team that actually works on this. So what they do is that they exactly know if a request comes from a certain person, where exactly that data of them is stored. So just like a post box, they will keep on putting the right data into the right place. So there is a big team that actually works on this. So multi-tenancy is a very important thing because we can't allot one server for each user account that we get. We have millions of users. Should we have millions of servers? Definitely not. So we will have less number of servers, but we will be able to cater to those millions of users mainly because we know how to do multi-tenancy. Multi-tenancy means just like hotel. So I have the rooms built. So depending on how it's being used, I will just dynamically allot people to the various rooms and then get moving. Then the other thing is stateless. So when I say stateless, it means the program should know that it is me who is asking for a resource, but at the same time, it should not tie me to a certain person. Let's take this case, right? So there is a big desk in which there are 4 or 5 people sitting. So you go with an application form. So when you go with an application form, if you first complete one section of that application form, right, and then you have a doubt, then you go back and then you are doing something and then you come back again. Now, if the whole system is built such that only if that first thing is known can the second thing be done, then you have to essentially send me to the same person, right? There are 10 people sitting, so I need to go to the correct person again and say, see, I was in 1, now I want to do 2. So you know about 1, so you help me in 2. Versus, you break the whole activity that you do into chunks, right? So 1, 2, 3, 4, everything is stateless in the sense that if I do one with one person, with one server, I can take the next request, put it into another server and continue from 1 to 2, to 3, to 4. So I don't essentially depend on, let's assume that there was one server. Now this happens in our government offices, right? So the clerk will be there, everybody will be going to the clerk, he will go for lunch, that's all gone, right? So what happens? Whatever is there, that paper will be there. Assume that he took the paper and then went for lunch. You can't do anything about it. Gone. You have to wait till that paper, that person comes and lifts the paper, right? So this kind of system will not help in the case of cloud computing. So what we should do, we have to actually make the system itself stateless in the sense that I don't really care about whether this is the first step or the second step or the third step. I keep on distributing the resources to multiple people, and each server will do the job, and in the whole job will be done. Then horizontal scaling, I already talked about it. Then redundancy also is redundancy. So in the office, when you actually buy a server, let's assume that we have bought a say 50 lakh server, big server. You will not buy 2 or 3 or 4. Immediately the auditors will come and say, why are you spending so much on the resource, or why are you spending so much on the computer? Because it's all costly, right? Why? Because each of them are supposed to function with a very high accuracy and with a very high availability, right? But in our case, we think that failures will happen. It is human to fail. It is good for the servers to fail. Let them fail. But for each failure, there will be lot of redundancy that will be built in. By redundancy, there will be lots of servers we will provision. For example, if we need 3 servers, we will actually have 10 servers. Why? Because those 10 servers are not as costly as those servers that sit in your office. These are small Linux boxes which probably do not cost much. So we will put multiple. And what we will do, we will have a load balancer in front, and that will actually look at each of those servers and find out if some server is going for a cup of chai. So it will take out the request from there, it will give it to the other one. Since there are 10 already, even though you need only 4, so you can dynamically keep on distributing the load. Then the other redundancy that we will build in is also, say for example, you have this happened in Chennai, by the way, right? Most of the Airtel and all the telecom networks went down after the floods. Anybody guess the reason? And I think most of even the TV stations also were having a big problem. All of them are on the side of Adayar near Ikatutanga. Most of them, right? Most of the towers, then they flooded, then there was a big issue, and then they were not available. Now, for that, what usually we do, I mean, this is a typical case for the mobile, you need the tower to be in that place. But in our case, the data can be in any place, as long as it is available. Whether it is available in the east coast of US or in the west coast of US is none of anybody's business. As long as the data is available, if one whole area goes down, for example, west coast is prone for earthquakes. So some big earthquake event happened. So will we shut the shop and go? No, we cannot, right? So what should we do? So we should have a redundant. So basically we will copy all this data and keep in another place. The moment something happens here, this happens very frequently for us, and it is not an issue at all for us, because we will keep on switching. Okay, this is the problem, I will just throw this off, I will serve from that end. Then from there I will serve for some time, and then I will switch to this. So I can keep on doing this. So the reason being, everything is synced. So there is a copy, redundancy. There is a copy of something there in one side, is also kept on the other side. Everything will be duplicated. At all levels there will be duplication. The switches, the servers, okay. So the servers, the switches, even the databases, everything is redundant, right? And then dynamic provisioning and efficient networking. So the networking also is like, we use some technologies like BGP. So for example, if the network is, one network cable gets cut, automatically the system will know that this network cable is cut, and it will actually send the data to the other location. So this is all done by some efficient networking protocols. These are all very difficult to implement in a in-house situation. Okay, so this is what I was telling you. There are not just only one type of cloud. There are multiple types of clouds. So one is called the IaaS, which is the infrastructure as a service. The other one is platform as a service. And then the third one is the software as a service. So Zoho is software as a service. Platform as a service, again you have Amazon, they have some services that they offer as a platform as a service. Google Cloud Platform is another such thing. And IaaS is an infrastructure as a service. So what do you mean by infrastructure as a service? You will get some place to store your data. You will have a database. So these are available. Now this is where you have to look at, so if you just see the key at the bottom, so just because somebody is implementing cloud does not mean that every responsibility goes to the cloud. So what the cloud is going to, so in which model, what is going to be the responsibility is what is shown in this slide. So the blue ones are the cloud service provider, typically people like us, our responsibility. And the grey one is actually the customer's responsibility. So what does that mean? So customer also has got some responsibility. So that is why when I said, when you actually have agility provisioning, the people and the data there on the top, right? These are the people in the customer location, the people in the customers, they should know how to use the stack. They should be configuring it properly. If they don't configure it properly, even though all this available, so in case of Zoho, from physical network on till applications, we take care of everything. You don't need to worry about anything. But you still need to find out like how much, for example, the number of accounts that you want. So let's assume that you have bought some 10 licenses and there are 15 people trying to access, right? So that licenses, so typically the case that happened in the NRC, the license was not properly managed. So when one person goes, you have to remove that person from that account. If you don't remove that person from the account, there are two problems that you will face. One is that person outside of your organization can still go and access this because this is all public. In the sense that public, in the sense that it is available outside your boundary of the organization. So if you don't do that, the other person, he will sit conveniently outside and do all the things that he was doing within the organization. This is a risk. The other risk is you will lose your license. That license, which is basically not being used, for which you are paying, so then a genuine user comes in, he will not have the license. So these kind of things, nobody can actually fix. I mean, the cloud service provider cannot fix it for you. It has to be so the people. So if you know about this networking model, there is something like this kind of a stack that we study in engineering. So it used to start from somewhere in the network and then slowly go to various protocols, and then finally it will say application layer protocol. That is what they usually say. Now that is called 7 layers. So they used to say 7 layers of, 7 layers of. So typically what we say is there is 8 layers. That 8th layer is basically the people. Now you do whatever engineering you want in the 7 layers. If the person who is sitting on top of that is an I starting and ending with T, right, is an idiot. Not any amount of thing that you build in can only work to some extent. Because that person can do anything that you want with that particular system, right? So similar is the case here. So if you move from IaaS to SaaS, so in a Zoho kind of a situation, you don't need to worry about all these things. But you still need to worry about configuration, giving access controls. I'll come to the security. When we come to the security, I will just explain how this thing works. Now, and in the case of a PaaS, so till runtime, what do you mean by runtime? You can write the code and keep. For example, if too many people come, then you fire some 10 servers. Like that you can write one code and keep. So the moment that 10 more people log in, automatically the 10 servers will be started. Those kind of things can be done at the runtime. Till that level, the CSP will give you a provision to do that. You still have to write that code. That application has to be written in that case. Similarly, in the IaaS, till the hypervisor, I was telling about the big computer which can have many virtual machines and stuff like that. So till that hypervisor, the control will be with the cloud service provider. But you still need to put the correct OS there, configure the OS correctly, put the security patches. When a new Windows security patches come, you have to upload it. The CSP will not do this. So whenever you are dealing with cloud, you have to be very clear as to what cloud you are actually dealing with. Depending on the cloud that you are dealing with, the responsibilities will change, and based on that, the risks also will change. So when you go for an audit or something like that, you can have this in your background and then ask that question. When you are you using a software as a service? Now, how are you ensuring that the resources are not being wasted? So what kind of controls you have? Who looks into that system within your organization? Who is provisioning? Who is deprovisioning the things? So these are all the things also that needs to be looked at. Otherwise what will happen is, you will be actually spending too much of money not using the resources properly. Then this is the other model, other type of cloud services. This you can hear. So when you say cloud, usually it means something that is available outside and which can be consumed from anywhere, right? So that is why we call it as public external. Sometimes what big companies do is they replicate something in their organization itself. Some big companies, they will have their own private cloud. But then what they will do, for normal times, they may use their cloud. And just like you were talking about GST, so they have some, let us say, some process where they have to submit every, let's say, process the payroll. So at the end of the month, they will burst into a public cloud. So for normal access, to check whether the pay is credited, those kind of things that the normal, what the people do, there will be a cloud that is running internally. Then they will have a public cloud. So whenever there is this huge number of requests that come in, then they will burst into, seamlessly they will use that also as a part of the resource. So this is the other. So here also you have to be very careful how you are bursting from the private to the public cloud. Now I'll come to all the pressure points. So sir is asking even after that, why was this a problem? So there are a lot of problems also. So I will just try to tell what are all the problems, and then I will come with ISACA's guideline on what should you really look as an organization. If you want to go to cloud, what are all the principles that you have to actually look at? So first let us go through this one. OPEX not going through reviews. As auditors you will completely understand this. CAPEX, big ticket item, you do an audit, you will immediately see, oh, 1 crore rupees, 50 lakh rupees. Now in the cloud, what is going to happen? Every month, 50,000 rupees, 20,000 rupees, something like that will be going. So, is there a proper review for even the OPEX that is going on? Because for a CAPEX, there will always be a review, because it's going to be a big, huge amount. There will be multi-level approvals, all those things will be there. Initially, probably to contract a cloud service, somebody would have signed an agreement. That time they would have done all research, everything. After that, it is all in the hands of the operation folks, how they handle it. Duplicate accounts, junk accounts, accounts that are not properly, and you are paying. So this is like a salami, right? Slowly some money will be leaking out of the organization. You will not be even knowing that this much of money is going out of the organization. So OPEX not going through reviews is one of the things that as auditors you have to look at. So how it is different. Then vendor lock-in and portability. Now this is not a big problem now, but earlier it was. So what is vendor lock-in? Say for example, this vendor lock-in is basically there even for the in-house deployments also. For example, let's assume that you went with SAP. It's very difficult to get transferred to some other system, right? To move that from one SAP system to some other system, let's say XYZ system, is very difficult. But in the case of a cloud, you have put all the data in the cloud. The data itself is outside. At least in this case, the data is inside. There the data is outside. So if the data is outside, so what if that company goes bust? What is going to happen to the data? So these are also things that we have to look. I mean, the people in the customer side of the engagement should look into. Maybe take another set of backup, which they handle it in a separate place. Then is there a portability when you evaluate? So for example, when you come to Zoho, we always give the portability option. Most of the cloud service providers today, they give a portability option. So you close an account with us and go. We'll giving you an opportunity to download all the data in some kind of a format, CSV format or something, that you can go and import it into some of the other competing services that are there. So the same thing happens. And even when somebody comes from outside, each of these cloud service providers, we help in moving them from that system to this system. So this vendor lock-in and portability is not a big issue, but you have to be very attentive when you are actually evaluating a cloud vendor. Then operational risk of geographical distribution of data. So this probably is going to happen in a few months. I'm not sure to what extent. So I think in the new data protection bill that is currently under discussion, so one of the things is called localization. So what they mean by localization is that they want the sensitive data of Indian citizens to be kept only within India, and they don't want it to be outside. Now let's assume that you have a data center in US and suddenly there is a big issue, and then the data is all, so some country says disconnects. This happens in Iran, most of the countries, right? They censor the data. China censors. What will happen to the data? Because of the geographical spread of the data also, there is a risk. So that has to be factored in. So these are all the factors that the customers should do. Just because the cloud service is available does not mean that you don't have any risk, or we just need to just simply sit and enjoy the cloud service. So these are some of the things. Then issues related to joint tenancy. So let's assume that there is a competitor A and competitor B. Both of them are using the same cloud. Now what happens? That is one thing. Second thing is, in some regulations, I think this IRDA regulations and some other regulations, they may say you should not share certain things with other people or other outside the company or something like that. I'm not sure, but I'm just saying, if there are some regulations, then what do you do with joint tenancy? How can that be factored in, right? So these are some of the, then outsourcing and reliance on third-party contracts. So whenever we do cloud computing, we are actually relying on a third party to actually do the job for you. So the contracts have to be tight. So that's why I told, if the contract is not proper, so if the contract was not negotiated properly even at the start, even if the Infosys is not able to provide that kind of a service, you can't do anything about it because the contract is not there. The contract does not specify. So that's why it is very important to include things like your SLA and the uptime requirements, support requirements, whether you will get the support all through the year, 24/7 by 365, or it is only 5 days a week. All these things have to be negotiated as part of your third-party contracts. Mobile device data protection, the shifting arc boundary. Now, if you just open this mobile phone, has got my complete office because we offer the software as a service. Entire thing is available as apps here. So where is the organization boundary here? The organization boundary is in my mobile phone. So what do we do for that? So there is a mobile device management software that is running. So that will, so if I just go and tell my IT team, I lost my phone, they will be able to remotely wipe. Irrespective of whether you have configured it or not configured it, they don't leave it to us. They will take the call. And the accounts will be locked. All these things they can do. So this also is a very important facet. So these all things need to be done by the customers, not by the cloud service providers. So how are you going to do mobile device protection? Then monitoring and reporting, I have already discussed this a lot earlier about how are you going to monitor your usage and reporting security incidents that you feel. For example, somebody is repeatedly trying to log into your account. Will you set up an alert for that? The CSP may have their own mechanism, but you still need to have your own mechanisms to take action on those.
Ransomware.
Huh?
Ransomware.
Ransomware. Okay, ransomware is more about that happens in your organization on your laptops and stuff like that. So here what we are talking about is, say for example, you would have seen these mails in Google, right? Somebody tried to access your account from
Repeated keying of wrong password.
Repeated keying in of wrong passwords. Now the cloud service provider will definitely notify you that somebody is trying to actually key in passwords, but you should have a plan for that. As a customer, you should have a plan for how to react to that. Whether you should ask the person to change the password, or whether something else needs to be done, whether it is to be reported to the police, depending on the severity of the or the sensitivity of the company. Like a normal company may not really care, but if it is a very highly sensitive this one and somebody is trying to hack, then there should be some bad procedures for this. So shifting the risk management from the governance to operations, that's what I told you. Usually, if you want to do anything in an organization, the governance will come and say, now this is how everything will be managed. Now, this is now slowly getting into operations, because 90% of all the things that I am saying about how to manage your cloud is in operations domain, not in governance domain. If the operation goofs up, whatever level of risks and controls that you put in place, nothing is going to help. Right? So these are all the pressure points in the computing. So now, based on all this that was discussed, that is about how the characteristics of the cloud are, and what are all the pressure points, what are all the benefits and everything, ISACA has come up with a cloud computing guiding principles. So I just put them here. So the principles are enablement principle, cost benefit principle, enterprise risk principle, capability principle, accountability principle, and trust principle. So if you just have a look at that, you will get a broad idea as to how to approach a cloud company, or when you go for an auditing for a cloud company, these are all the principles that you can probably touch base on. As an information security auditor, we have to do this, but as the auditor that does the financial side, you can also still, cost benefit principle is something that you can actually focus on, whether the real cost benefit is accruing to the organization because of the adoption of the cloud. Then risk, of course, enterprise risk principle. Then enablement principle, what it is, essentially says is that don't think that cloud means outsourcing. Cloud is not outsourcing. Cloud is how you are able to make your strategic vision of the organization fit into the cloud. So if you just think as, oh, I have outsourced this job to the travel desk, I have outsourced to somebody. This software will do it. For this software, I will this cloud service will. No, you have to look at the complete enablement. I mean, how this your strategic vision is going to get enabled. For example, we have something called as Zoho One. So we started with a lot of products, Zoho, small products. Now we have a suite called as Zoho One. So now if you take Zoho One, this almost covers all the ERP kind of software. Now the advantage would be, with just one account, you can seamlessly use all the software. So from your strategic perspective, you can think about like, and the cost will be very less when you actually do that volumes. So then in that case, you will be able to run your whole company there using Zoho. But for different people, you can have different kinds of the software that's being used and stuff like that. So the strategic vision is basically about how the certain cloud that we are trying to use. Say if you are going to use Gmail, look from the perspective of the strategy. What is this that this strategy is going to give for the company? Then capability principle. So you have to integrate the internal resources fully with the cloud. So just the cloud is there, I will have an account, I will have 10 accounts, I will just do something. For an organization, it is not useful. It is just for exam, for just testing it out, it's okay. But if you want to really adopt it, it will have to be actually in sync with what is the organization goal. Accountability principle is very important. The boundary should be very clearly defined. I have already shown how in IaaS and PaaS and SaaS, the accountability changes depending on which kind of a cloud you are using. So this is, and then the trust principle. This is the basic thing when you actually trust in the cloud. The data that you think is of the organization is now publicly available. Publicly in the sense that it is available in some public place. Earlier, some 30 years before, all this data would have been inside, sitting inside the organization. Now it is available outside. So the cloud service providers and the customers, they are having a trust here. So the belief that the private information in the cloud remains private and outcomes expected from the use of the application will be realized. That is, when it is needed. Again the same example. When the GST has to be filed, the GST application should be available. If it is not available, then you are basically losing the trust. So that's what is happening, right? You are asking this question because the trust principle is lost. Now if you actually look at all this, you will be able to figure out how the cloud computing principles are and stuff like that. So with this, I think kind of I am coming to an end of the cloud computing portion. Now let me go into security. So we first started with computing. So we discussed how the computing and everything happened from mainframe to cloud. Then we just focused on cloud, the cloud alone. So what does the cloud do? What do you mean by cloud? What are all the important things that we need to know about the cloud? Now let's come into security. So what I am going to tell here about security is I am going to only discuss about principles of security and privacy. So from there, a lot of interesting questions may come, or maybe you can also, look at few use cases, and then you can just try to relate the security and the cloud. And then in the final session, we will try to merge these two and see how well these two are merging. So security and privacy. So even before I start, so if somebody asks, define security, or give me the attributes of security. So what are the attributes of a security?
Unauthorized person should not access to the data.
Okay.
Protection of data.
Protection of data. Unauthorized person should not access the data. Okay. So
Safeguarding. Should not get destroyed.
should not get destroyed.
Loss of data.
Loss of data.
Loss of data. It should not be lost. And the third principle is what the sir was saying. It should be available.
Whenever you require.
If it is not available, I have protected everything. See, solid, this one, my data is inside a 10 feet wall. Yes, good. But is it available? To the person, again, not to everybody, to the correct person. Right? So, we have actually arrived at the security principles. So, protection of the data, unauthorized people should not actually access the data, protection, deletion, the data should not be lost, right? And then,
Any chance that data will be corrupted?
very good. Corruption of data. Corruption of data is also a, so I took deletion of data, he actually added the correct term to that. Deletion of data is a kind of corruption, is another kind of corruption. Corruption also can happen. So corruption of data is also a problem. So now if we go to the next slide, you would see that you already know security. You don't need an expert to say what security is because you already know it. So this is security. Availability, confidentiality, integrity. When you say corruption, integrity of the data is not there. When you say the data is not completely gone, again integrity of the data is gone, completely deleted, not available. Availability means it should be available when somebody requests the resource. So I paid you money for accessing my data and you are not giving me that data. So it's a loss of security. And just because I want to give availability does not mean that I open the availability to everybody. If this is my IT returns, only I should be able to see the IT returns, not everybody. Right? Or probably the income tax officer who is going to basically look at my returns, only these two people should see that IT returns. Right? And here there is an interesting stuff. What is confidential may become non-confidential also. So when it becomes non-confidential, the controls have to go. Can somebody give an example? This is very much useful for the auditors. I mean, auditors day in and day out you use that basically. Give me one example where something needs to be confidential but will become public later, so it should not be confidential.
Like financial
File
sector.
with ROC.
Correct. So the filings with ROC, initially when are the balance sheets, the what is called the year-end statements, year-end
Financial sector.
financials, all this should not be available before the end of that, till that time it has to be protected, it should be confidential. But once it is in the public domain, when you have the shareholders meeting and all those things, that time you will not say, this is confidential data, I won't share this confidential data to you. So the confidential data does not simply mean that one data once classified as confidential will always be confidential. Now that is where the difference between privacy and security comes. In privacy, the data is always confidential until and unless the person chooses to make it public. So anything about me is confidential. I mean, no ROC, anything cannot make it public, right? So even if it has to be done, for the select set of people only it has to be done. For example, criminal records. Will everybody know about the criminal records of everybody? No. It's not public, right? Some of the data is public, some data is not public. So in the privacy and confidentiality there is this slight difference. So confidentiality does not mean that it will always be confidential. So what does that mean? The security itself has to be dynamic. It cannot just set a set of rules and say that this is a set of rules for this particular data, you cannot change it. No, it has to be flexible also. So depending on what that data is, at what point of time, what is required, that has to be provided. That is security. So the three, so interestingly, if you just look at CIA, these are the principles of security. CIA, Central Intelligence Agency, confidentiality, integrity, availability. Right? So easiest way to remember. So this is security. Then something there on the top of security is privacy. Now, in the privacy, what you additionally do on top of security is that you do a limitation. If you don't need, I am going to sell apples to you. Please give me your Aadhaar number. To sell apples to you, a person who is having a small shop, if you ask for the Aadhaar number, will you give it? You won't. It's not needed. Purpose is not there. There is no purpose for collecting an Aadhaar number for selling a fruit. So, then again collection. Sir, you write this form, sir. Sir, another form, sir. Duplicate, sir. Triplicate, sir. This, sir. That, sir. Sir, first day in the bank you fill this form, sir. Second day also you have to fill the same. Why do you need? You have once collected the data, put it into the system. Why do you need it repeatedly? Right? So that is limited collection. And then there should be a defined purpose. Then there should be a limited use. This limited use thing that I can very easily explain to you. You go to any of the trade fairs, at the entrance, they will ask you the telephone number, your mobile number, right? To get an entry into the pavilion. Now, why are they collecting it for? First of all, is there a purpose? We can ask. Why are you collecting it? Second thing is, you should only use it for that purpose that you actually told that you will be using it for. That is, sir, we are collecting it because we will share this information with the pavilion owners. So when the next big house comes, we will contact you. Now, the next day, you will get an SMS from not the real estate, something else. What does that mean? The purpose has not been properly, the use has not been limited, right? That is a big violation. In European geographies, like we operate in Europe and all, this is a big sin actually. We can be penalized for that. And then limited retention. All of us know, right? Grandfather's papers, grandfather's father's papers, all that collected and then kept, right? Why do you need that for? What do you need that for? We just don't know. So if you need income tax returns for 6 years, keep it for 6 years, 8 years, 10 years, this one, 100 years. And if you want to sell it as a item, what is that, archaic item, and then getting some money, that's a different matter. But then limited retention. In our case, by storing lot of data, we are exposing the threat boundary. Because more data means there is a possibility that if there is a small leak, lots of data that is not supposed to be there with us would also get outside, right? So that is the problem. And limited disclosure, of course. So why, if you ask me, suddenly you come to my office and then say, see this customer, you give me all the details. Why would I give? I should not give the details. Whatever is there, limited disclosure, whatever is supposed to be given, even for the law enforcement, we have to supposed to give only based on the subpoena, right? When somebody, when the court orders it. Just because somebody, so anybody will phone up as say, I am this SP, you give me your data. We cannot give, right? So limited disclosure. Then consent. This is very important. There should be the consent from the individual. If it is not there, then that data cannot be actually handled. So this roughly talks about the various principles of security and privacy, right? Now, this is another Venn diagram I am trying to make here. So you have privacy on one side, you have security on the other side. So whenever we talk about security, what are we talking about? Confidentiality, integrity, availability. We are just ensuring that the data is secure. Now on the right hand side, it is not always about just keeping the data safe. It is also about the rights of that individual. If the individual has a certain right, it is my responsibility to honor that right. If that is not honored, that person's privacy rights are actually violated, right? So on the privacy, it is not just about some simple principles, it's also about the rights. These are, privacy by the way in India is a fundamental right, right? That's what the Supreme Court has ruled now. So it's a fundamental right. So it has got very strong legal background for in the case of privacy. Then you have this personal data security. The intersection of this both is your personal data security. So you have to keep the data secure, and if there is a privacy right, you take care of the privacy right angle. But then the data that you have collected ultimately has to be properly secured, which is the personal data security, and that should have a higher level of protection than the normal data security. You should always think about both the facets and then design the security and privacy. Now, I think you have already understood the security. Well, let me just dive a bit more into these concepts, availability, this one, and see how it can be implemented. So again, once again, how to define availability. So the availability is guarantee. So just look at these few words. I will come back at another slide where I will try to relate some of this with how these things are actually implemented. Right? So guarantee of reliable access. So the access should be reliable to information as required to authorized. To the authorized people only you have to give, peoples and users. So when required, reliable access, guarantee of information. So this is availability. Let's go to confidentiality. When we go to confidentiality, protect from unauthorized observation or disclosure, in transit or store. Transit means when something is moving from one place to another place. Store is when something is getting stored. So the data, when you are accessing the web service or some service, so the data, your username and password travels from your browser to the cloud. There, your data is stored, and from there, that data has to come to you, right? So this in transit and store, unauthorized observation and disclosure should not be there. This is what it says. By a set of rules that limits access to the information. The information can be only accessed by the rightful people. So that is what confidentiality is. So we are just trying to break these terms into some small words and then see how we can try to implement them. Next we have integrity. So integrity is an assurance that the information is trustworthy and accurate. So it's not corrupted. If it is corrupted, then it's gone. So it should be trustworthy and accurate. Protection from malicious creation, alteration, deletion by an unauthorized attack. So if it is unauthorized, then also there is an integrity problem. Now, so I can just show you the 3 slides again. Can you just tell me what is the common thing or the common word that is there in the 3 slides?
Authorization.
Authorization. Okay, so authorization is the key word that is there in all the 3 slides, which means that for availability, for confidentiality and for integrity, you need to take care of this authorization. So authorization is the common word across all the principles. Now the question is, what is authorization? So how do you define authorization? So what are all the components of authorization? If I say authorization, what are all the components? Any guess you want to do before?
User ID login.
User ID login, okay.
Who can do what?
Look at what you want.
Who can do what?
Who can do what? Very good. Okay. So user ID, who can do what? Okay.
Biometric.
Huh?
Biometric security.
Biometric, okay. Okay.
Restriction to
Huh?
restriction to information.
Restriction to information. Okay. Okay. Restriction to information is what happens because of the authorization. But I'm just looking at what are all the components of authorization.
Delegation of limits. Delegation of limits.
Delegation of limits, I think both are the same, but okay, but that's also correct. Delegation of limits. Yeah, good. I think you people are experts. I'm not needed here. Okay, so I'll go to the next slide. You will almost find everything there. Okay, somebody said user ID or something, right? Yeah, that is identification. So these are the four terms are very important here. So in order for the authorization, you should have an identification first, which is your user ID or whatever you call it, right? So that's first portion. So he told the first portion. You told biometric.
Boundary control.
Biometric, password, whatever. That is your authentication. You authenticate yourself. You tell that, okay, you are the user, you authenticate or you tell that you are the person who is doing the job. So that is the authentication. Third is the authorization. So you told about the various levels and this one. So basically it is about the roles, responsibility, permission, for what role, what should be available, what should not be available. So that is, even though it's called authorization, but so it also comes under the same thing. And the last thing is, you auditors know very well, non-repudiation. So any idea what non-repudiation is?
Non-cancellation. Non-cancellation.
Non-cancellation.
Cannot deny.
Cannot deny. Yeah, you cannot deny. Why it is important? You do bank transaction now on the cloud. Basically, when HDFC Bank is giving you something, it's running on the cloud somewhere, right? It's not definitely within their, it's in a public place and then you are using it. So I transfer some money and they say I never transfer, you give back the money to me. So how will you prove? Similarly, I send a mail, right? I give an authorization to the bank, you transfer X amount of money from this account to that account. Then you come and say I never sent. This is not me. Right? So authorization is also about non-repudiation. Non-repudiation means you cannot deny this. Now let's look at how can all these principles or components be implemented in a...
Sir, will OTP come under non-repudiation?
Not really. It is it is usually called as two-factor authentication. Authentication, so usually how will you authenticate yourself? Either who you are, what you have, right, and what you know. What you know is a password. Usually, it's a password. So I am the user. I know my password. What you know, what you have. What you have is fingerprint, whatever. And the third one is what you know, what you have, and what you have is this OTP stuff like that. Password is what you know. The OTP is sent after you enter the password. That is what you have now. The second factor authentication. The second factor authentication that has been given from the bank to you, which you have right now, on top of what you know. So you have two factors now. Then the third one is what you are. So what you are is your biometric. If you put your fingerprint, that is your what you are. So these three are usually the authentication methods. It can be a password, it can be an OTP, and the other can be your biometric. So if you take these three, two-factor authentication means these days in most of the places in cloud services, in fact even in Zoho we say always implement two-factor authentication. Now this implementing two-factor authentication, who should do? User. Customer has to do. The facility will be available in the application, but it is the customer who has to use it. If it is not being used, you still don't get the security that is available, right? So these are some of the things you have to always be. So just because there is a cloud, the customer does not absolutely have no responsibility. That's not the case. You still need to do all these things. So now I think authentication is clear, right? Now authorization. So authorization, how do we do? We have the roles. For this section of the code, somebody can look into it. This section, somebody can. This section of the, or for example, in banks, certain value of transactions can be only taken by somebody. People for RD, some department may be there. For PPF, another department may be there. So they can only view that. They cannot view this one. All those things are there, right? So this is authorization. And how is authorization done? The authorization is actually a framework that is built on top of the authentication framework. So once you get authenticated, then you get authorized. So first you have to open the gate, identify yourself. Kulja Simpson, Alibaba, Narpal, first you get into it, and then you go into the various places where the data is, and then you have to get authorized. And then once you get authorized, in certain transactions, you should be able to prove, or the system should be able to prove, the cloud system should be able to prove that it is this user who has performed this operation, and this is undeniable. If this is not built into the cloud software, it is very difficult for trust, right? So what we do for that is digital signatures. These days I think digital signatures have become very common, right? Most of your filings, everything, I think you do it with digital signatures. So digital signature, if you want to just, I'll tell you what basically it does. So I have an information with me, right? It's a lot of bits and bytes, right? Lots of bits. Okay, leave even bytes, it's all bits. Now even if one bit is changed, the information is changed, yes or no? Right? So I should be able to find out if one bit is changed, right? So for that, there is a technology called hashing. So what the technology does is, you give any information to that. So it's a software. You just give that information to it, or an algorithm, right? It will actually convert it into a big number plus digits, whatever, big one. Now you change one bit in that, and then again pass through the same function, the value will be different. So this is one method for actually finding out if there is something that has been tampered or not. So this function is called hashing. Now what you do after that, so everybody knows about encryption, right? So do you know the various types of encryption? Like, okay, I want to share a secret information with you, let's assume. So how can we share the secret information? They should not know about it, but we both should know about it. So how will we share?
Like a code.
Like a code. You also know the code, I also know the code. So we both will use the same code, right? So this is one kind of encryption. So both of us know the same code, which means that anybody else outside does not know. But unfortunately, you also have the code, I also have the code. Now, the problem is non-repudiation cannot happen here. Why? Because you also have the same code, I also have the same code. So I will take something, put it, and I will say, no, I did not do it, he did it. So non-repudiation cannot happen with this kind of a code. So this is good for storing information. So I will have a code, you give me a code, I will use the code and store it. Nobody will be able to see, even we people, right? We people inside the Zoho, we will not be able to see the information because the code was given by you. Sometimes we have also that, you can give in the browser and it will stay with you. And that will be used and used for encrypting the things and then putting it into our things. So if you forget that code, all data is not available, gone. It's your responsibility to keep your password or the secret safe. Right? So now, the other thing is, there is another kind of encryption, which is called as the private public key encryption. So that is why whenever you talk about certificates and all, they talk about private key, private key. So you have idea about that, right? So public key means that key is public. Means it is available to everybody. They can use that. They can, for example, I can use your key and encrypt certain thing. Right? Now that information cannot be seen by anybody. But again, it will not prove non-repudiation. Why it cannot prove non-repudiation? Because even if he takes that same key and then encrypts it, then also it will be the same. Right? So this is one. Then there is another private key. Private key is something that is private to you. Only you have that. Now, if I use a private key, the only thing that can actually change, open that is the public key. Even though the public key is public, it can give the proper information only if I had used the proper private key. So this is actually used for your digital signature. So on one side you use hashing basically to find out that nothing has been tampered with, and on top of that you use this private key of yours and put this hash itself into that some kind of an encrypted stuff. Now if I use you, so for example if I am doing that, you take my public key and use that on that particular data that I have sent. I am sending you a data, a bank statement. That bank statement is public, let's assume, or some letter. I am sending you a letter. That letter I have written something, that letter comes to you. Now you want to check and find out whether the letter that I have written is the same. So along with the letter I will also send you the digital signature, that is the hash of that letter. So as I wrote, I will do a hash and I will send you. So at that point of time, whatever bits and bytes were there in that message, that will give you a hash. And on top of that, I will put my private key and sign and give it to you. So now when it comes to you, you will put your public key. My public key is available everywhere. So you will put the public key. Then you will get the hash. Now what you will do, you will take the message. You also have the same hashing function. Hashing function is the same. It's the same program. You put through the message through the hashing function. You will get a value. Now after decryption, from that you have another value. Now both of them, if you compare, if they are same, then what does that mean? It means that the message has not been altered and the message was sent by me, because the private key of mine, you used the public key of me and you got the correct message. So this is what a digital signature is all about. So digital signature is not some complex technology. That's all. Very simple. So this is all done in the background. So non-repudiation is actually done this way. So authorization is a common thing across the three. But is that authorization the only word there in the three slides? There are many others, right? So let's now look at each of those subsequently. Now let's take the case of availability. So what were the words that we saw there? Guarantee. So what is a guarantee? A guarantee is an SLA. So whenever you talk about availability, the cloud service provider has to say, my availability commitment is this. Right? So for that, an agreement is very essential. If that agreement is not there, and if the service is not provided, nothing can be done, because there is nothing to back the claim. And importantly, it is the job of the service provider to look at this guarantee and design the system. So once this is clear, then the system has to be designed. Now the next one is uptime. So uptime, as I told you, how to increase the uptime? Redundancy. So by building redundancy, if one thing goes down, okay, another thing will take over, and similarly. So that I explained already. So uptime, again availability, redundancy. Third is reliability. This also I already talked about. So how can I make the system reliable? I will just horizontally scale. So keep multiple machines in parallel to do the same set of jobs. That is to break the loads. So if, for example, I will not have just one server, all the requests will come and hit that one server, and once the limit crosses, then it will completely go down. No, that's not how it is. So you will have instead 10 for this, 10 for this guy, 10 for that guy, and then all these guys, they will work together. And then the last one, resilience, is known good replacement. Let's take this case, right? Whether it is done by the customer or whether it is done by the cloud service provider, assume that there is a massive corruption of the data, right? Will the information be available? Integrity is not there is one point. Let us see how it affects the availability. Is there availability? No. Because the data is corrupted. Okay, integrity is gone, but availability is also gone. Because you don't have the reliable access to the information. So what do you do for that? So periodically we should have the backups. And so the known backup, so even this, the service provider has to tell you. So we have typical terms for this, which is called recovery point objective and recovery time objective. So how further, at what, I mean, what is the point of recovery? From what point will you get the data? And then what is the recovery time? How much time will it take for you to actually recover and give it, right? So known good replacement is very important. So this has to be built into the system. And I would suggest in cloud cases, even the customers can have periodic copy of the things in another place if they want. Because even if something gets corrupted there, they can actually take it back from the system and then put it. Because with the sync, what happens, this happened in the case of Microsoft, if I'm right. So even before I go there, so I talked about a lot of encryption and all those things, right? Can encryption affect availability? Yes or no?
Yes.
How?
Every time when you take the data, you have to decrypt.
Ah.
Right? That is time consuming. Okay. And depending upon the technology that you use, if that becomes corrupt.
Yeah, so first point is that the whole process of encryption and decryption itself takes some time, because of which there may be, rather than availability, I will say the performance may not be that good. But you will still get the data, but even if there is an SLA like everything has to be done in 2 seconds, maybe that thing can suffer, but still it's more a performance problem. The second point is, assume that the key is lost, like you gave a key to me, to the cloud service provider, and the cloud service provider lost the key. The data is encrypted, or you stored the data in the cloud and the cloud service provider generated a key, and using that generated key the data was stored. Some problem happened, the generated key in the cloud service premises went off or gone. What will happen to that information? That information is permanently lost. Right? Huh? You can't do anything with that, because you can't decrypt it, because the key is lost. So a key lost, an encryption also can trigger an availability problem if the key is lost, right? So in the case of Microsoft, it so happened that the keys in probably one data center, they usually keep replicating, right? So you do something here, the same thing will get replicated in another place. That is how we build redundancy. We have to, otherwise what will happen, if one fails, then the whole system fails. Now the problem with that redundancy is also, the redundancy is automatic. So if I delete something here, it happens in many cases, sometimes customers will accidentally delete something, all the records. That's all, gone. Every record will be gone. Whatever happens in the primary will also happen in the secondary. Everything will get replicated. So similarly, in there what happened, the keys got deleted both places. So the only way they could recover is from this known good replacement. So known good replacement is very important for the resiliency. Otherwise what will happen, everything is okay, system is up and running, service is running, servers are running, there is lot of capacity, we have big bandwidth, everything is there, but data is not available. Irundum illama podum, right? Irundum illama podum, availability loss தான். So we call it as, so this is about availability. Now let's go to integrity. So am I going too far above this one, or is kind of understandable? Is it okay, or? Because these are technical terms, but I am just trying to make it simple so that you can understand how security actually is built by small technologies. Now next is integrity. So trust in the, now at any stage if there is a problem, corruption that can happen, ultimately everything will get corrupted. This is what you do in your trial balance accounting, everything, right? So you have to do it at every level. Every level, if the things are proper, then it means that at the end everything will tally. Otherwise it won't tally, right? Same thing here. So if I created something, at that creation itself I corrupted something. At the end, whatever output you get, so you actually keyed in 1 or 2 in the web browser. I processed it as 5. What happens? In the creation stage itself, the corruption has happened. Right? Next is alteration. So some malicious program, some virus, something went inside, changed everything. All 5s were converted into 10s. Right? And the third is deletion. Without proper deletion of keys that I was talking about. So without a proper deletion mechanism, all things got deleted. So in either of these cases, the integrity will be lost. So for the creation, what we have to do? Verification. So what we typically do is like whatever you enter, we will have to check on the server side as well. So has something changed from the server side to this side? So there is also a mechanism for, so in our software, so we write the software, right? So if the person who wrote the software did not write the software properly, then also this problem can happen. So we have to have lot of verification mechanisms. So at every stage we will go through some kind of security audit checklists and stuff like that. So ensure that the code itself is not a problem. Then the alteration can happen because of a bug that we put. So sometimes what will happen, you have a condition. If x is equal to this, you do this. So somebody changed that. Instead of x is equal to something, they said x is equal to everything. Which means what it will do, it will go and change everybody's. For example, I have a notebook and I have put a lock on the notebook, let's assume. Right? Now, this guy who is writing the code, or the person who is actually putting a virus or whatever, what that guy does is, he says, open the lock of customer A. Right? He processed, opened the lock off, but forgot customer A. Now what will happen? Assume that everybody had notebooks. Customer A is gone. If customer A is gone, what does that mean? Open lock of everybody. So all locks across notebooks, notebooks which are there in across the world, everything will be open. So this is how some of these simple errors that you see, right, in the, like so many things were opened up or whatever is made available. These all happen because of very, very simple, silly bugs in the code. Then deletion. So for deletion, we should have records. If we don't have records, or something called as log entries, right? We keep on log entries. If we have the log entries, we can actually recreate that. If we don't have the logs, so just like you have your logs, so databases have the journal logs. So they have the journals where they keep on. So every time a certain instruction is executed, it will keep on logging that instruction. So what you can try to do is you can take a known backup and then run this completely. If you run this completely till the time when you thought that deletion happened, you can actually recover all the data back. So these kind of things. So journal log entries. So these are also there for integrity checks. Now let's come to the confidentiality. Now protect from observation and disclosure. In transit, SSL and TLS, and in store is for encryption, right? So I think I have talked about encryption and even SSL, TLS. When we see HTTPS, so how many people actually bypass when the HTTPS error comes? So you type in HTTPS something, Google says the certificate is not valid. So what do you do?
Most of the time alone.
Huh?
Most of the time alone.
Most of
If it is a known reliable check, you go. First time you are doing it's not.
Okay. With most of the Indian sites, does it say the certificate is not valid? I think so. Most of the government websites I have seen.
Yeah.
So why is it that? Huh?
It's unsecure. It's unsecure.
Actually, so what is really happening in the background is, so whatever that private key, public key stuff that I was saying, right, it still is working there. It's using the same thing only. It's a bit involved, so I won't go into the details, but still this is what happens. So you cannot use this public key, private key that I was talking about is a very taxing system of encryption. it is very difficult to encrypt and decrypt because it takes a lot of resource. So instead what they will do is, I and you have to share a certain key. That initial key exchange, they will use this public key, private key to basically share that key. Once that key is shared, I will encrypt always all the information using that key, and you will actually decrypt using that same key. So this is what is done in the SSL TLS. Now the problem is, I and you can actually negotiate a key. But I trust you, you trust me, we can do this. Now, I am the cloud service provider. What should I do? For each and every person, what should I do? Should I do like this? That is, with you as a single person I can do. But if I want to cover all the people here, is it possible for me to go and verify that I am the person? So for that there is a certification authority body or certification, there are certain companies that actually provide you the certificates. You actually pay to them. So they will use some encryption on top of this to prove that this is me. So if you see https zoho.com or whatever, and if you see a proper certificate, it means that certificate company, so you are basically trusting that certificate company. So that certificate company is guaranteeing that this site is Zoho.
Like ISO 27001.
No, this is not a standard or something. This is actually a technology. It's a technology. So the browser actually does a lot of things validating all these things. Now for all these things to happen, this certificate giving authority, right, has to be in the browser. If they know about that certifying authority, only will they be able to process anything further from that particular the certificate. Now, if you look at the case of Indian sites, I think we are not part of the browser, or most of the browsers don't carry the default certificate or something like that. This is actually something that's very dangerous, because since this does not work, so what we actually do is we keep on skipping this. So tomorrow if somebody makes actually a site which is not correct, we will still say and then go and give the information. So this is one risk that I have seen in most of the government sites have this problem, because I think the browsers don't carry that certificate, or some of the certificating authorities of India are probably not recognized. So this is what I can think of. Now, so SSL TLS is very important.
And when we log in through Google Chrome, earlier we used to get this HTTPS, but now it's not. Like for example, if you log on to Axis Bank, you type Axis Bank, Google Chrome, you don't get that in the path.
You don't get HTTP or HTTPS.
Nothing. Just
So,
Axis Bank,
okay, another thing that is happening. Yeah, another thing that is happening is you can still find out. How you can find out? If you just go to the left hand side.
Lock kind of thing.
Yeah, that lock will be there. If the lock is there, it means that it is, it is secure. But I will tell you one more thing. Even in Zoho, what we have done is, we have slowly phased out HTTP at all. So we don't offer HTTP at all. So you type http zoho.com. What we will do is, we will take that request, convert it into HTTPS, and then we will redirect you to HTTPS. Why? Because anybody can put an http zoho.com, and you won't know the difference between http zoho.com and or z0h0.com or something like that, right? So you will not know the difference, and you can simply go and give the username and password. Number one. Number two, the username and password that you are submitting on websites which don't have HTTPS, when they travel through the wire, they travel unencrypted, which means the username and password can be seen if you want to see. There are methods, right? I can put a site in between, and I can actually get all the username and passwords. They will not be encrypted. So that is the issue with the HTTP. So what we are doing as service providers is, it's actually for us, if you say, it is actually a tax on us. Because as he was saying, encryption and decryption has got a tax. Because it's an activity. So I give you a request and you process and give it to me. Instead, I give something to you, you immediately you will take one paper, put everything inside, cover it, pack it and give it to me. Right? So if that is the difference, right? Like for example, I want to give a packet. So you can take information as some small packet that I have to give. Now every single time I request an information, you take that information, you put it into some cover, seal it and then give it to me. So this takes some time. And on my side, to process that, to take that information, I have to again open the cover and then see. Right? So this is taxing. But we want to be sure that customers' information is safe. So you can see majority of the major cloud service providers don't offer HTTP anymore. So you type HTTP, they will take you to HTTPS. We do it, Google does it, most of the cloud service companies have started doing it.
And when we try to use the laptop in hotels where we go, is it secure?
Okay, again, so this is Wi-Fi access, right? So we are talking about Wi-Fi access. Here again, this open hotspots without any authentication, that is danger. Your information is not safe at all. Anybody can snoop.
We can't do, not advisable to do net banking.
No. Okay. Now this is where this HTTPS helps. You still do HTTPS on top of that. That HTTPS will ensure that your information is safe.
Open Wi-Fi also.
Open Wi-Fi also, but I would not actually advise that, because see, one thing with security that we have to remember is that whatever we know about security is what we know, right? There are, so what we call as zero-day vulnerabilities that are being exploited. I'll tell you an interesting case. I told you about SSL, TLS, what great encryption mechanism is. You cannot find the information and all. Actually, most of information in Google and other places were snooped upon in US because there was a vulnerability in this SSL handshake itself. What was happening was, so I told you that in the SSL TLS, we are basically exchanging a key, right? This exchanging the key is what is being done there. Now, there was certain predictability in the way in which this key is being shared. So if you know just one key, you can predict all the other keys. So once you have the key, whatever information is there, you can immediately decipher. Right? So zero-day vulnerability still exists. So that is the reason why I would suggest that it's better not to use open Wi-Fi, stuff like that. So best is to use WPA2. So even in the house, when you actually configure something, it's better to use a WPA2 encryption. I think, yeah. So WPA2, see there are okay, from your computer to the wireless access point, something is happening, right? So information has to go through wireless. Now, if I say encryption, there should be some standard way of me and that router exchanging some information, this computer and that router, so that whatever goes in the air cannot be read by somebody else. So there are various methods by which you can do it. So WPA2 is the most, right now, as things stand now, is not breakable. The encryption is not breakable. So now I won't say that this would be forever. As things stand now, it's like that. So even I told you about hashing, right? So earlier we used to have a hashing scheme called as MD5. MD5 was the hashing scheme. Now they found out that if you use MD5, there is no guarantee that whatever was given. See, I said for every piece of information there is a unique string that is generated. Now in MD5 that uniqueness was lost. So then they said no, let us go to another software. So like this is an ever evolving field, and that is why you will keep on, even in SSL and TLS. SSL and TLS is not just, again, this is another interesting thing. So SSL TLS is not just about what the service provider does. It is also about what you do. Now, there is a problem with this TLS. I mean, the TLS, there are different versions. If your browser supports the older version, then it will try to negotiate with the server with the older version. Now, if I don't support in the server the older version, you will not be able to access my data. That is, availability is lost. So there are a lot of things like this. So the service providers like us, we will keep on giving information to you. Please move from this to that. So this is how you need to configure your machine, so that this is not. So there should be somebody sitting in the organization reading this and implementing that. If that is not there, whatever be the security that we build in the cloud cannot be actually practiced on the ground. Two-factor authentication, HTTPS, certificate management, domain management. If you have the domain, sometimes you can purchase the domain. So how do you keep the domains, the name of the domains? How do you keep it properly? In one case, I think Twitter, if I am right. So one engineer actually was using some Gmail account. In that Gmail account, he was having some password for Gmail account. See, passwords also are very important. Now, this is an incident that happened a few years before, maybe like 6-7 years before, maybe. So this is what happened. Now, somehow, one hacker got hold of this Gmail account. So he knows the password now, right? Then what he did, he used the same password. So he found out from the mails that this guy is the guy who administers the domain of the Twitter. So for example, if I write twitter.com, this twitter.com, what twitter.com is something that happens in the backend, right? Some domain name gets transferred into an IP address. I will not go into the technical, but this is maintained somewhere. So if you say twitter.com, you go here for that. Now, in the directory, if I go and change from instead of twitter.com to my own server, I have a server sitting somewhere else, I change it to my, all the requests that will be going into Twitter will be coming to this place, right? Now, what happened was this hacker, since he knew the password, he guessed that he may be using the same password across all the other accounts. So what this guy did, he went into his, so most, for example, if you go for domains, there will be some service providers like GoDaddy or some common service providers. He went to their portal, used this guy's email ID and password, got into it. So those times there were no this two-factor authentication and all, no SMS, nothing, no OTP. Went inside, changed the Twitter down. You hit to Twitter, it will go somewhere else. This one thing happened. Another interesting thing happened with our neighbors. They actually brought YouTube down. And I say neighbors, you understand, right? Pakistan. So what they did, so I said that there are a lot of networking protocols that are there which actually does this routing. So I told that I can actually say, I can advertise that I am at Nungambakam and I am at Central. Okay, with two different frequencies, whatever. I'm just dumbing it down a bit, but two different things. Now, the moment I am down here, all the traffic will go into Central. Let's assume that I have two offices, two phone numbers. This phone number is also there, that phone number is also there. Both of them are in a giant, what you call as the pooled phone number. Now this phone goes down, automatically all calls will land on the other phone, right? Similar to that, this one is there. Now YouTube has some number in the internet space, the IP address space. Now what these guys did, they advertised, they actually wanted to block the YouTube. So Pakistan government wanted YouTube to be blocked. So the guy who is sitting there, the network administrator, he went and changed the YouTube's IP address space, and all requests to YouTube started flowing into Pakistan. So you will not get YouTube. You will get some Pakistan IP address. So all these things are possible at a giant scale. Even there are some such risks like that, which are being constantly rectified by means of more such signatures and authentication mechanisms and stuff like that. So they're just interesting side stories. So things can break, and can break in very interesting ways. But still, at the end of the day, if you practice a lot of this internet hygiene, so just like coronavirus only, so you practice the hygiene, then you don't get into much of this problems.
Sir, is it safe to allow remember password in case of HTTPS?
I don't do it. I never do this. And the reason why I don't do this is I actually use a password manager for that. So I actually have the password manager in all the places, wherever I want, and everything is like has a username, password, everything like that. So anytime I want, I will see that password and then I will type into it. So I don't usually keep them, this remember stuff I don't do. I am very paranoid. So since I know a lot of things that can happen, so I actually try to limit my use of those things.
Which is
Now,
the best antivirus
best?
Antivirus.
See, now antivirus technology itself is moving in different directions now. So earlier, what used to be is like, there is some signature. If this signature is known, then this is a virus. Now the problem is that you must keep on updating this signature, right? Now what is happening is they are moving slowly away from even antivirus technology to what is called as endpoint security. Now what is endpoint security is something like this. Whatever be the virus, whatever be the programs that run, unauthenticated, unauthorized programs that run, what do they do ultimately? They try to access something that they are not supposed to access, right? So again, go back to coronavirus stuff, right? Coronavirus will go and affect your body. Yes. But they go and do something which they are not supposed to do. Right? The similar thing happens in the computer virus or computer programs also. Now, the moment something goes and touches programs that are not supposed to be touched, there are now integrity mechanisms available in the operating system itself these days. So what they call as in Windows, they have a specific name for it. So they have, like, all programs will operate in a certain space. Now if you cross the boundary or attempt to cross the boundary, that time itself it means that there is some problem. That is, you get sneezing, then you be worried. First point. So you may still not have the virus, but sneezing means that there is something there, right? So similar to that, it is happening in most of the OS. Now what people are doing is, they put an end agent there. This end agent will keep on looking at such kind of violations. Any program, it may be even your own program that is jumping a boundary and going somewhere. Some wrongly written program. A developer writing a program. Right? So now what happens? These are all again sent into a cloud. Again, there is a cloud infrastructure that is available. All these inputs, just like your traffic data coming from your phone, another person's phone. Similarly, this is happening these days. This data is massively fed into the cloud. That cloud will check how many such things are happening across the world. And based on that, it will proactively come and stop a program from executing. So this is what is happening these days in the antivirus field. So they have moved on from signature, looking at the signature, whether this is a virus, that is a virus, all those things. They have gone to what is called as the endpoint security. There are lots of players there who are into this field these days. So this is what is happening in the antivirus space these days. So they are not looking at the program signature and stuff like that. So whenever you actually run an antivirus program, it will say updating signatures, right? What is updating signature? So it will say if this file type comes, or if this file has got this, I said MD5 or whatever, right? So you put something, so when something comes, then they will check, and then, oh, this is there, so this must be a virus. Something like that. From there, they are moving on to this.
But it's become redundant. Antivirus as such, you mean to say it has become...
No, I am not saying it is redundant. What I am saying is that it is no longer sufficient, effective, because such is the number of computing devices. Any person can actually create a antivirus like this, virus like this. So how will you track? Somebody does in the morning in Japan, person in US is sleeping, and before that person actually wakes up, half of the world would have been infected. There's another, you know about this MERSK, I don't know how to pronounce it, the shipping, giant shipping, masks. So, you know what happened to them?
Ransomware.
Yeah. So, their whole operations was down. And you know how they actually came back online?
Paying the ransom money.
Actually, there's interesting stuff there. So what really happened was, so they had this Active Directory system. Active Directory is where you use a centralized system to authenticate all the Windows computers. So in organization, some 1,000 computers are there. Will you go and put username, password everywhere? So you will have to maintain it in some common place. So what generally people use is Active Directory, which is a Microsoft product. Now, that Active Directory was in multiple locations. It was all synced basically. So what happened? All the corruption happened in every place. So nobody can authenticate now. So that is what happened. So I am just actually making it very simple for you, but it's kind of technical. But this is in the end, this is what happened. Now, there was this one computer or one of the offices in Africa, deep in Africa, with a very bad internet connectivity. That alone did not suffer. So, one engineer flew down from Africa. So, that African nation is something like, it probably has a very one flight or something, or even there people are not allowed to go, something like that. So, one person traveled from there to some intermediate place. Another person from, I think, London or some place, he flew to that place with that hard disk of that computer. So they then went and plugged this hard disk in their server, and then from there they actually brought that up of request. Okay? So, is it Greek and Latin now, or do you think I can continue in the same way, or do you think I have to change something? Continue, right? So this is not Greek and Latin, right? I am able to convey what in a simple terms, right? Okay. Now let me go to the... So now what we are trying to do is to understand what this whole cloud computing is about, because the cloud itself is like what you can call that elephant story, right? People talk about cloud. So one person looks at the legs and thinks cloud is this. Another person looks at the trunk and then he thinks that that is what cloud is about. So we use cloud a lot, but we still don't know very much about what the basis of the cloud is, what do you mean by a cloud, and so what's the definition, what are the characteristics. So what is the benefit? I think many of you would know about the benefit, so I would let you talk about it. And then implementation, yes, implementation, how is it implemented, what are all the backend, what do they do it to implement, issues, and then the other thing, right? Okay, so whenever we look at the definition, whenever I come to a presentation, I just look at some standards because they usually try to explain a complex subject into something that is very simple, right? So this is the definition of cloud as per NIST. So NIST is the standards body of United States of America. So they have a lot of guidance on a lot of subjects, and this is about cloud computing. Okay, so these are the words. Ubiquitous. This is a model. So cloud computing is a model for enabling ubiquitous. Any idea what ubiquitous means? Prevalent, everywhere available, right? Ubiquitous, convenient, on-demand network access to shared pool of configurable computing resources, rapidly provisioned and released. So I have just tried to make the important words bold there. So ubiquitous means it should be available, widespread availability. Convenient, it must be convenient to use, it must be imperceptible. We should not be doing a lot of configurations to access that service. Even a layman should be able to use it, assuming that the person knows the domain. For example, I have a finance software. So I must only know the domain knowledge of how to use the finance software. I should not be really worried about what happens in the back end. You have to do the right click, left click, nothing. So you just go and then start using it. Convenient. On-demand network access. So on demand, you should be able to actually access the network to fetch the resources. And recently in the cloud paradigm, we also support offline computing. So we can store a portion of the data in your local machine, and we can sync as and when the network becomes available. Because when you move on a mobile network, you don't actually get the permanent connectivity. The connectivity can go and come, right? So on-demand network access to shared pool of resources. The resources are all shared. So it's just like a hotel room, right? So it's the data center is shared by millions and millions of people, right? So that's the shared pool of configurable computing resources, which means the computing resources can be configurable. For example, today, let's say ESPN or something, right? There is a India-Pakistan match. So the number of people will be more. So I should be able to ramp up everything and then serve most of the people. And then there is some Afghanistan versus Ireland match. So I don't need those many resources. I can bring them down. So right. So configurable computing and rapidly provisioning and released. So you can rapidly provision. So at the click of a button, you will say add 5 more computing resources, add 6 more computing resources, extend the endpoint to multiple geographies. So these kind of things you will actually do a click and point and start. This is what you will do, and then at the back end all these things get automated, and then the resources get provisioned. So this is the cloud computing definition, right? So now let's go to the characteristics. So this slide is just the extension of the previous slide, right? On demand nature. Yeah.
This GST side, most of the time it crashes.
Which one?
GST side, when the number of users are very few compared to the Google users, that's why we are facing this problem for last 2 years.
See, so this is very important in cloud computing, right? The most important thing with cloud computing is that how well you are able to manage the shared resources. I'll give you a simple example that can happen in a hotel. We'll take a hotel, right? So how many of you have an engineering background or a science background here? Okay. So you heard about Poisson distribution, right? So let's assume that I am running a hotel. So how many rooms should I have? Is a question. So I am going to start a hotel now. how many rooms should I have? Now this is a common problem. When there is, let's assume there is a Tiruvizha somewhere, right? Just on the Tiruvizha day, there will be lots of people. So what will happen? Rooms will not be available. But on days when there is nobody there, all the rooms will be empty. So what do you build for? Do you build for the Tiruvizha or do you build for the lean days? We will build for something in between. So there is this Poisson distribution which will estimate based on things how many people come. So they will say at this point there is a probability that when the crowd is this much, you will be able to cater to these many set of people, right? Now, I think the GST problems, usually what I have heard about, I may be wrong, you are better informed on that. It all happens during that phase when all the people try to go and access the site. This happens even with the IT also, I mean the IT returns also. Why go that far? IRCTC, Tatkal, right? So, basically Google and Microsoft, those people, they have unlimited computing resources. When I say unlimited, the amount of provisioning that they do for this computing resources is very huge. I mean, they, for example, for everybody they give you about what? 25 GB of space or 10 GB of space or 5 GB of space. So how much of 5 GB you are going to use? I mean, 5 GB now is not a big amount. I think they give about 20 GB or 25 GB of space. 25 GB, how many of us will be using? Right? So they give you 25 GB, but they know very well that you are not going to use 25 GB. So they will do planning for that. So I would think that it all depends on how you plan for it, and there can be two reasons why this thing happens. One is the real computing power problem. The other is the network problem. If the network is also not provisioned properly, then also you will have a problem. That is, there is lot of, it's just like our Madras roads. Wherever Chennai, there is this bridge work going on. You will see that that side will be free, this side will be free. Just the place where there is this road work going on, you will have tight congestion. So you will not be able to reach there. You will not be able to reach there only because of this constriction. So network is one of the reasons why it can be, and the second reason can also be the improper provisioning of the computing resources. The computing resources have to be estimated. So the estimates have to be done. Okay, if these many reports are going to be filed, so how much are you going to invest in that? So this is actually a very big area within cloud computing. So the major cloud computing providers, including us, we will keep on evaluating the performance. In Zoho, for example, each and every machine actually looks at how loaded it is. Each of this is actually collected, just like sensors. You have sensors in all the machines. It will tell, okay, one machine may actually have a faulty network card. It may have lots of resource, but it may have a faulty network card. So that will not be able to serve. So all this in the back end, you have to constantly keep on watching and then throw some servers out. So sometimes you will throw some servers out because they are actually slowing down the system. And instead we will provision new. All this needs to be automated, and this is actually a big science by itself. So I can't answer for who is running that, but this is kind of...
Infosys is handling it.
Actually, they have officially admitted that the peak availability 1.5 lakhs users. That officially they have declared.
So that is what they have provision for. So it all depends on, as we go down the line, we will see how you have to actually, how availability is important, and then, so first what you have to do is your SLA. You have to first determine what is your load, and based on that you have to build your infrastructure, right? And even one...
What is the solution to this recurring problem? We are facing every month, we are facing.
The solution is basically you increase the computing resources, right? So increasing the computing resources, I mean, you have to understand what really is the problem. So I can give you some examples. For example, very early in our history, this is about like 15 years before, if I'm right, 50, maybe like 13 years before. there was this new pay commission that was announced. So one public sector employee did an Excel calculation of the new pay structure and he put it on the Zoho, right? It so happened that that particular service almost came to a crawl, because Zoho is like, we, at least in the case of GST, you know what the application is going to do. In our case, we also don't know what application is going to be used for. It can be used by anybody, right? So we make available software which is used by everybody. Now what happened, that is when we decided to do this one. So when we actually went and looked at the problem, we found out that it was because of this one page which was having too many requests, and the too many requests did not have sufficient capacity in the backend. I am talking about lot of years before. So but we learned from that. So what we did was, we used that as a test case, and then we understood that we have to not just monitor the amount of traffic that is coming in, because usually the kind of pipes that availability is lost. So there are a lot of things like this. So the service providers like us, we will keep on giving information to you. Please move from this to that. So this is how you need to configure your machine, so that this is not. So there should be somebody sitting in the organization reading this and implementing that. If that is not there, whatever be the security that we build in the cloud cannot be actually practiced on the ground. Two-factor authentication, HTTPS, certificate management, domain management. If you have the domain, sometimes you can purchase the domain. So how do you keep the domains, the name of the domains, how do you keep it properly? In one case, I think Twitter, if I am right. So one engineer actually was using some Gmail account. In that Gmail account, he was having some password for Gmail account. See, passwords also are very important. Now this is an incident that happened a few years before, maybe like 6-7 years before maybe. So this is what happened. Now somehow one hacker got hold of this Gmail account. So he knows the password now, right? Then what he did, he used the same password. So he found out from the mails that this guy is the guy who administers the domain of the Twitter. So for example, if I write twitter.com, this twitter.com, what twitter.com is something that happens in the backend, right? Some domain name gets transferred into an IP address. I will not go into the technical, but this is maintained somewhere. So if you say twitter.com, you go here for that. Now, in the directory, if I go and change from instead of twitter.com to my own server, I have a server sitting somewhere else, I change it to my, all the requests that will be going into Twitter will be coming to this place, right? Now, what happened was, this hacker, since he knew the password, he guessed that he may be using the same password across all the other accounts. So what this guy did, he went into his, for example, if you go for domains, there will be some service providers like GoDaddy or some common service providers. He went to their portal, used this guy's email ID and password, got into it. So those times there were no this two-factor authentication and all, no SMS, nothing, no OTP. Went inside, changed the Twitter down. You hit to Twitter, it will go somewhere else. This one thing happened. Another interesting thing happened with our neighbors. They actually brought YouTube down. And I say neighbors, you understand, right? Pakistan. So what they did, so I said that there are a lot of networking protocols that are there which actually does this routing. So I told that I can actually say, I can advertise that I am at Nungambakam and I am at Central. Okay, with two different frequencies, whatever. I'm just dumbing it down a bit, but two different things. Now, the moment I am down here, all the traffic will go into central. Let's assume that I have two offices, two phone numbers. This phone number is also there, that phone number is also there. Both of them are in a giant, what you call as the pooled phone number. Now this phone goes down, automatically all calls will land on the other phone, right? Similar to that, that's a situation. This one is there. Now YouTube has some number in the internet space, the IP address space. Now what these guys did, they advertised, they actually wanted to block the YouTube. So Pakistan government wanted YouTube to be blocked. So the guy who is sitting there, the network administrator, he went and changed the address space, the YouTube's IP address space, and all requests to YouTube started flowing into Pakistan. So you will not get YouTube. You will get some Pakistan IP address. So all these things are possible at a giant scale. Even there are some such risks like that, which are being constantly rectified by means of more such signatures and authentication mechanisms and stuff like that. So they're just interesting side stories. So things can break and can break in very interesting ways. But still, at the end of the day, if you practice a lot of this internet hygiene, so just like coronavirus only. So you practice the hygiene, then you don't get into much of this problems.
Sir, is it safe to allow remember password in case of HTTPS?
I don't do it. I never do this. And the reason why I don't do this is I actually use a password manager for that. So I actually have the password manager in all the places, wherever I want, and everything is like has a username, password, everything like that. So anytime I want, I will see that password and then I will type into it. So I don't usually keep them, this remember stuff I don't do. I am very paranoid. So since I know a lot of things that can happen, so I actually try to limit my use of those things.
Which is
Now,
the best antivirus
best,
Antivirus.
see, now antivirus technology itself is moving in different directions now. So earlier, what used to be is like, there is some signature. If this signature is known, then this is a virus. Now the problem is that you must keep on updating this signature, right? Now what is happening is they are moving slowly away from even antivirus technology to what is called as endpoint security. Now what is endpoint security is something like this. Whatever be the virus, whatever be the programs that run, unauthenticated, unauthorized programs that run, what do they do ultimately? They try to access something that they are not supposed to access, right? So, again, go back to coronavirus stuff, right? Coronavirus will go and affect your body. Yes. But they go and do something which they are not supposed to do, right? The similar thing happens in the computer virus or computer programs also. Now, the moment something goes and touches programs that are not supposed to be touched, there are now integrity mechanisms available in the operating system itself these days. So what they call as, in Windows they have a specific name for it. So they have, like, all programs will operate in a certain space. Now if you cross the boundary or attempt to cross the boundary, that time itself it means that there is some problem. That is, you get sneezing, then you be worried. First point. So you may still not have the virus, but sneezing means that there is something there, right? So similar to that, it is happening in most of the OS. Now what people are doing is, they put an end agent there. This end agent will keep on looking at such kind of violations. Any program, it may be even your own program that is jumping a boundary and going somewhere. Some wrongly written program. A developer writing a program, right? So now what happens? These are all again sent into a cloud. Again, there is a cloud infrastructure that is available. All these inputs, just like your traffic data coming from your phone, another person's phone, Similarly, this is happening these days. This data is massively fed into the cloud. That cloud will check how many such things are happening across the world. And based on that, it will proactively come and stop a program from executing. So this is what is happening these days in the antivirus field. So they have moved on from signature, looking at the signature, whether this is a virus, that is a virus, all those things. They have gone to what is called as the endpoint security. There are lots of players there who are into this field these days. So this is what is happening in the antivirus space these days. So they are not looking at the program signature and stuff like that. So whenever you actually run an antivirus program, it will say updating signatures, right? What is updating signature? So it will say if this file type comes, or if this file has got this, I said MD5 or whatever, right? So you put something, so when something comes, then they will check, and then, oh, this is there, so this must be a virus. From there they are moving on to this.
But it's become redundant. Antivirus as such, you mean to say it has become...
No, I am not saying it is redundant. What I am saying is that it is no longer sufficient, effective, because such is the number of computing devices. Any person can actually create a antivirus like this, virus like this. So how will you track? Somebody does in the morning in Japan, person in US is sleeping, and before that person actually wakes up, half of the world would have been infected. There's another, you know about this MERSK, I don't know how to pronounce it, the shipping, giant shipping, Maersk. So, you know what happened to them?
Ransomware.
Yeah. So, their whole operations was down. And you know how they actually came back online?
Paying the ransom money.
Actually, there's interesting stuff there. So what really happened was, so they had this Active Directory system. Active Directory is where you use a centralized system to authenticate all the Windows computers. So in organization, some 1,000 computers are there. Will you go and put username, password everywhere? So you will have to maintain it in some common place. So what generally people use is Active Directory, which is a Microsoft product. Now, that Active Directory was in multiple locations, it was all synced basically. So what happened? All the corruption happened in every place. So nobody can authenticate now. So that is what happened. So I am just actually making it very simple for you, but it's kind of technical, but this is, in the end, this is what happened. Now, there was this one computer or one of the offices in Africa, deep in Africa, with a very bad internet connectivity. That alone did not suffer. So, one engineer flew down from Africa. So, that African nation is something like, it probably has a one flight or something, or even there people are not allowed to go, something like that. So, one person traveled from there to some intermediate place. Another person from, I think, London or some place, he flew to that place with that hard disk of that computer. So they then went and plugged this hard disk in their server, and then from there they actually brought that up, that Active Directory. So this is the kind of story that I read. So interesting things. Even so, sometimes unavailability is also good, in the sense that you are able to bring the thing back up again. Right? Right. So I think confidentiality, we can just, so we have covered almost all the concepts. Now let's come to privacy. And then I'll just finish off with the what we do normally, right? So I have taken this privacy principles from the OECD guidelines. Now, why am I talking about privacy to you? Privacy is going to become something, it's the next in line. Actually, my designation is also Data Protection Officer for Zoho, which means that I am more involved in this privacy and security matters, primarily towards privacy. So, in fact, I am actually the representative for the customers within Zoho. So I have to speak your customer's voice, and I need to be aware that their rights are not being violated and stuff like that. So that's my actual primary job. So the privacy is, so if you see here I have written collection limitation, use limitation and purpose specification. So these three can be called as reduce. So on one side you have to reduce, and then you have to put security safeguards on them. So if you talk only about security, you go to a security engineer, you give him any data he will accept, and whatever rules you say, I want this to be confidential, I want a digital signature to be there, I want this to be happen, I want this to be available, the controls will be designed and put. He will not ask why you collected the data, how is this data collected, what is the purpose, no questions will be asked. Whereas if you go to a privacy engineer, the privacy person will ask all these questions. Why is this collected at first place? There is a good interplay between security and privacy here. So if your privacy practices are good, you reduce the amount of data to be protected in one way. Useless data you won't keep, because this guy will always come and ask you, why are you keeping this data? Why did you collect this data? All these things, right? So this way, there is a control over the amount of information that is being collected. So that is one thing as with the privacy. The good thing about privacy that is beneficial for the security. Now this is one interplay. Then the other thing that we are talking about is, as I said to you, privacy is about a rights problem. It's a rights question, right? So it is about people's right. So that is what it says, individual participation. What does that mean? So today, what I am supposed to do, if some customer says, I don't want any information of mine to be stored in your system, or give me all the information that you have about me, I have to ensure that these things are given by Zoho to that person. The person has got the right to ask the data. So marketing mails, if they are being sent, it has to be sent with consent. Not just like, sir, sir, insurance. In India it happens, even though after you go and sign up for what you call that, do not cross, I don't know whether that works at all. But if you violate somewhere in Europe, you are done and dusted. I think, if I'm right, British Airways, not British Airways, I think Honda or some company basically sent marketing mails, they were fined. Because if you send a marketing information to a person who has not asked for it, you should not. So these kind of things are the individual rights or individual participation. And similarly, the individual can tell that my data about me held in your system is wrong, you have to correct it. It is the job of the service provider to correct it. They cannot simply say, for example, somewhere it is, I think this was one of the big lawsuits between Google and a person. So that person said that, why is my information coming in Google search? My information should not come. Or my information is inaccurate. So inaccuracy, this will also not be tolerated. Then the third thing is the other side that I am talking about is the responsibility here, which is about openness, data quality and accountability. What does openness mean? At the point where I actually collect the information, I need to tell very openly why I am going to use that information for. So if you go to Zoho's privacy policy, there will be two sections. One is the big legal section, but before that there will be a small section where in English, basically, when I say English, not legal English, small simple English, we will tell you why we are going to collect this information. What if we get your name, why do we get? If we get this, why do we get? All this is written in the privacy policy. So we are supposed to follow it by whatever we have written. So every single time something comes to me, I will first check whether it is written there. If it is not written there, no, you can't do that. Or you go and change that. inform everybody, then start doing it. So such kind of transparency and openness should be there. Then the data quality I was talking about, so the data quality should be correct, and then accountability. So the organization is accountable for the private information of people, of the information that has been collected. Now, so we started with computing, then we came into cloud computing, then we talked about security and privacy. Now we have done everything, done. So cloud computing, security, my topic is over. Now implementing data protection. So you talk all these things, right? How actually do you implement this? Or what are all the n number of things? I can't probably give you exact details, and not exact details in the sense that it's very exhaustive, right? Very technical. But I'll try to make it as simple as possible and then tell you what typically means data protection, what are all the things that organizations do to implement data protection. So the important thing that you see here is by design, by default. Now data protection is a new term that has come. So initially they were talking privacy, privacy, privacy. Now privacy is also called as data protection. Right? So it has got, because privacy inherently has got, so if you see that first figure that I showed, where you had this big blue balloon and then a red balloon, within privacy there is security. I mean, if the security is not there, whatever amount of privacy you do will not be useful, right? So by design, by default, testing and audit, these are broadly the things that are done for implementing data protection. Now let's just, so this is what we do in our day-to-day life to do security in cloud computing. So we first start with secure coding. So what does the secure coding means? Secure coding means all the code that is actually written is automatically checked if it violates certain normal conditions. So there is something called a static code analysis that we do. So then there are some OWASP guidelines. I mean, like you have in most of the web applications you have some specific usage scenarios where, because the browser and the server, they trust each other, so that this trust can be broken if certain things are not properly done. So for that you have certain guidelines how you have to implement. So all this is automatically tested. So if you find that there is something, that's a problem in the code, there will be an alert that will be sent. That code cannot be actually put into the checked in, right? So somebody will come and review and then do it, make it proper, and then it will go. Then secure build and testing. So that's what I was talking about. So there is a secure build also, build process. So when you say build process, what really happens is that lots of people will write code. It's not one person who writes this code. So you put lots of people who just write the code, put everything together, and this whole integration process has to be secure. Otherwise, what will happen? So earlier days, let's assume that n number of people are developing something, some code. One person who is developing the code has got a virus in his system. That person makes a build in that machine. That exe that we generate, will it have the virus or not? It will have the virus. Now you go and supply it to somebody. It will go into a client machine, and there it will start propagating the virus. Right? So all these things have to be taken care of. So how you put the build, how to ensure that these kind of things does not happen, all checks. So these things happen during the secure building. Then you have secure deployment. So what do you mean by secure deployment? So these days, earlier, Windows 98 will come, then for 2 years you will not see anything, then suddenly then Windows XP will come, then you will again for 2 years nothing will happen. Then that is how software used to be developed. Now today, in all these cloud computing stuff, we will push patches probably even every day, maybe even every 8 hours. That is how we work. Because everything is like agile, we do it fast. We will just, we found out a bug, that bug can actually affect lots of people. So what we will do, we will just go and immediately fix it. So that needs to be pushed to everybody, right? So then you have to push it in the cloud. So this deployment again, this whole thing will be automated and it needs to be actually properly done. Then you have secure configuration. Now secure configuration what? At both the cloud service providers end and also the customer end. I have talked a lot about this. Encryption, authentication, authorization, anonymization. So just like you have encryption for security, anonymization is for privacy. So in privacy, it is not sufficient if you encrypt the data. Because what happens is if the key is available, then you can still recover the data back. But in case of anonymization, say for example you want to have some old data, you have to anonymize it. Means that you need it only for a certain statistical purpose. If it is for a statistical purpose, you don't need the exact data. So you don't need to know that this person of this age of this is did this thing. Maybe. Or if you need the age and the location, you don't need the exact name of the person. You can probably have it as X, Y, Z. So those kind of techniques also are now slowly coming into picture. Then retention. So every data we should have a policy as to till when will we retain this and when we will remove it. Monitoring and alerting, of course. We have a lots of systems. As I told you, one of the things that I told when you asked about the GST question. So how we built our own monitoring and alerting systems at various levels. We have at various levels we have. At the network level there will be some alerting. There will be at the application level, at the OS level. So at various levels we build, and all of this get aggregated, and then you find out whether there is something. Then log recording and management. So you need logs. So so even in the logs with the privacy angle, we don't want the actual personal information, because sometimes we may need to actually store the personal information. We will mask that information and store, because what is not needed for us is the exact name of the person. We just need to know that from this IP address or whatever. So we just mask it and store it. Then independent security testing. So independent security testing also means that we have a red team in our organization. So they actually go and hack. Their primary job is to try and hack Zoho itself. We employ them. So they will keep on trying to find out some vulnerability or other. So we will have in very many different teams. Their job is to just do hacking. Then we also run a program called as bug bounty. So if there is a security researcher, so we give them an opportunity to report the bugs to us rather than trying to make money. So we will tell, if they submit a very good bug, we give them money ourselves.
Ethical hacking.
Huh? Yeah, ethical hacking. So we give opportunity. So we run a program for that. We actually give them money if somebody finds a bug and reports it to us.
There's one place in Jharkhand somewhere which specializes in
Yeah, their police department, right?
criminals who specialize in hacking.
There are actually these days, right? There are lots of people who are like.
Professional hacker.
So I will. So when you are talking about ethical hacking, one of our colleagues actually, he won a very big prize in Google. Actually, he found a very serious bug in Google. One of our colleagues in the security team. So Google asked him so how do you want to be remunerated? So he said, no, I don't want the remuneration. You send it to this Vivekananda, this one or something like that. He said, donate it there. So I don't want that money. I have done it only for the knowledge and he reported it. So he did not use it for his personal benefit or anything. So like that, there are people in other companies also. So there are some people there are some people within our company who go and find the problems in Dropbox also. So this is like a give and take. We have some people like that. Some people from there also will be contributing, and we are all. Our job is to make you people secure. So
Are you part of CBI?
CPE? No. Independence. So the cert in has the details I mean, with every company, I think certain now has a mandate to have the data of the person who handles security or something, but other than that, we are not doing it. And independent security testing, and then you have data protection impact assessments. So this is again, we'll go through, we'll ask questions. What if this happens? What if this happens? You write a risk, this one, all those things. Then incident handling and RCAs, so that's also part of our job, part of security. And then we have audits. Now audits, when I say audits, it's fully information security audit. Now you have an audit every financial year or whatever. Our audits are like, you just don't know. Today, with GDPR, there is a right to audit clause written, which means that any customer can audit us at any point of time. So we should be ready for any audit at any point of time. So that's what we are. So talking about audits.
Sir, what is RCA?
RCA is root cause analysis. Root cause analysis means, see, basically when some problem happens, the easiest way to solve the problem is saying that, so this person did not do it properly, that is why it happened. So this is how usually the incidents get closed. Otherwise everything, our system is, you know what, the best in the world. So that's how usually things are and then you will get one person go out or whatever. So that's not what RCA is. RCA is to understand what is the root cause which caused this, and then what should be corrected at what level, right? So then coming back to audits, so you were asking about ISO 27001. So ISO 27001 is the granddaddy of all this information security standards. So on top of it, there is this ISO 27017 and 27018. So 27017 is for cloud service providers like us. So there are some additional clauses on top of 27001 where this will cover topics like, I told you, right, that there is the customer and there is this cloud service provider. Between these two people, there should be some kind of an agreement, right? So this 27017 will test all those. So have you very clearly specified how to do it? So today I said you have to have two-factor authentication, you have to do that, right? But did I specify it in my website? Did I tell very clearly what should be done? So if somebody comes in, what does he expect? If somebody goes out, what does he expect? I mean, comes into the system, goes out of the system. All these things we are supposed to tell and document. So this, the auditors will come and check whether we are doing it properly. 27018 is equivalent to 27017, but this is for privacy, exclusively for privacy. How we are honoring privacy in our cloud security or cloud service provision. SOC 2, I think many of you will be knowing, right? You know about SOC 2 reports, right? No? Okay. SOC 2 reports is, so you know about the Sarbanes-Oxley Act? So this SOC 2 comes in that context. So let's assume that I am contracting another company. So that company is actually having the IT security. I mean, my data is with them. And what is the point in now doing an audit on me when the whole data is there? So you are going and doing some trial balance audit. You are depending on some system, and that system is not within the organization, it is in a third party. How will you trust that? So when you do the audit, you ask that company's auditor to provide a SOC 2 report. That report will get added to your report, and this will go. So like this chain happens. That SOC 2, we are supposed to do it, get it done. Then CSA is Cloud Security Alliance. So it's an alliance of all the cloud security providers. They have come up with a STAR certification program. Then OWASP is another method where actually this is about web application security alone. So they have a standard, ASVS. So all these are some of the, this is just only a sample. Just wanted to tell that we also do a lot of auditing. And so but it's not in the financial domain, but in the information security domain. It keeps us engaged. So with this, I actually come to the end of the presentation. Hope I did not drag and too much and it was boring or whatever. You still have some questions or anything? Thank you for a very, very patient listening.
Sir, when you are saying about privacy now, like Wikipedia data can be altered. Does that affect the privacy?
See, public data, if you take public data, right, I'll give you a small case that happened in, I think, Europe. So there was this church group, a small group, set of people, they went and took a photograph. Now one person in that group went and uploaded that photo in a public place. Now another member from that group went and told, this is against my privacy. So what they told was, you have to take out the data. Right? Public information, I mean, something about me is available in the public does not mean that you can use that data. No. That is the essence of privacy. You should either have my consent or you should tell me that you have collected that data and how you plan to use it. That purpose is very important. So privacy means something is available in the public means does not. And by the way, Wikipedia is like, there's no authenticity to whatever is written there. So
Google guides, local guides, they used to upload photos and the views and other things. Will it also form part of violations or something?
yeah, see, all the privacy laws that I am talking about in the context of GDPR, it is all well established. We still don't have a data protection law. That data protection law is coming. Now, once the data protection law has come, then all this have to be done. But then the problem is, having a law is one thing, implementing is another thing. So I don't know, like, and privacy, generally if you take privacy, lot of people think that privacy is being used for business manipulation, or manipulation rather than manipulation. I would call this as a way to control business or something like that. Like Europeans don't want their data to go so. But actually, if you go by the history of privacy, it is because of Europe's experience of how privacy can be misused, mainly with the Nazi whatever stuff. So that is why in Europe you will see it is still, it's again a matter of culture. Now I used to say this, right? If you, in Chennai, on every single day, you will see this, birthday notices and this, posters. Yeah.
Banners.
Yeah, banners. Birthday is still okay. There are for certain other programs also they put a big, yeah. So that's all privacy. In our culture we don't probably consider that as privacy or whatever, but in certain other cultures. So privacy also has a cultural implication too, in terms of like what is. So law, when it comes, then most of these things will be under the ambit of that law.
Celebrities are there, promoting their pictures, showing
No,
their
he's talking about private people.
No, privacy, yeah. So,
For example, in WhatsApp, when we are serving, we sign up for some terms and conditions, so we are agreeing that they may use it. But we put a profile picture, somebody else downloads it and uses it. Nobody has control.
correct. And that is why.
Facebook, you upload something, somebody can download and edit it and use it.
So I am not on Facebook, and I don't put my profile photo at all. If at all I put in one place where things are public, and so LinkedIn or whatever, there my photo will be there. It has to be there because nobody will want to interact with somebody, a faceless person, right? There it may be, but I don't use Facebook. I don't actually use in WhatsApp. I don't have my profile picture. No reason why you need it. And the children have to be educated a lot with all these technologies. They just don't know how much their data can be actually misused. In fact, I did this interesting thing when my daughter was very young. She wanted to be on Facebook. Very young. She was just in school. All my friends are on Facebook. So I said, okay, good. You want to be in Facebook? You will be in Facebook. Just give me some half a day time. And then I went and then I looked at the Facebook profile of all there. So that time Facebook was even worse. I mean, you can see all sorts of information. Then I asked her, this guy, is he a Rajni fan? This guy, is he a Kamal fan? This one, how did you know? I said, from Facebook. You want to be on Facebook? So then she, no, I won't be on Facebook. She's still not on Facebook. So if you can, I mean, the amount of information that we share without knowing is too much actually. Thank you all for the patient listening.
Thank you very much, sir. It was indeed a very learning lesson. I think all the members who are here patiently listening, it was really a very learning lesson, I should say, sir. Thank you. A big applause for sir for giving such a nice